Hello friends, hope you are doing well. I'm Narayan and in this class I'm going to discuss about Python. Python is a very popular programming language and it is very useful for data science. If you want to start your programming career as a beginner, then this programming language is suitable for you. Why it is suitable for you and why it is so popular, what is the benefit of learning Python. In this video we'll understand these points, and this video is going to be helpful for people who want to explore this particular programming language for data science related projects, or if you are a data science learner, or you want to learn data visualization, etc., or you want to develop software using Python, and you know nothing about coding and programming, and you are from non-technical background. So many qualities in are defining my student here, but it is a class on Python, so just like another Python class. So first thing first, what is Python? Python is a high level programming language, okay, and it's a general purpose programming language. Why it is called high level, what is general purpose programming language, we'll discuss all those things. Then first thing first, who invented this language? What is language? Language is just like a communication medium, like we talk to another person using English, Hindi, or Bengali, or Urdu. Similarly, if you want to communicate with a computer, you need a language. So I think this kind of basic basic concept you already have, so I'm not going to explain these again. But here, as you are going to learn a programming language, you have to understand some programming paradigms are some concept, okay? So these concepts are followed by different programming language. Do you know any other programming language name? I think you already know, like C, C++, PHP, JavaScript, and there are so many programming languages are available, and Python is one of them. But here it is claimed that it is easier compared to other programming language. So major feature is it is using a different programming paradigm that are useful for programmers. So what is programming paradigm? I want to discuss a little bit about this. Programming paradigms are the way of classifying programming language and based on their feature. So what are the features that a programming paradigm include? Features like whether it is procedural programming, whether it is object-oriented programming, whether it is declarative programming. So these keywords are new for a non-technical person. I totally understand that, but for learning this these points, just try to understand that common programming paradigms include: number one is object-oriented, which is group of instruction that part of state they operate on. Now all these things I understand totally new. Declarative is a programming that merely declare the desired result, and not how to compute it. There are some logical, mathematical paradigms also available. Logical, in which the desired result in and the declare as an answer to a question about the system and fact and rules. Mathematical paradigm is in which the desired result is declared as a solution of a optimization problem. And reactive paradigm in which the desired result is data streams and propagation of change. Just if you are not familiar with this, no problem. Once you are doing programming, you can understand them. You can also do some Google research or ChatGPT research on that. But most important thing is object oriented programming, which is commonly known as OOP. It is a programming paradigm based on the concept like object which contain data, and code. Okay, and object oriented programming is, as the name suggests, object oriented. So the data is the form of field, often known as the attribute or property of an object. So the code code is the form of procedure or method. So a common feature of object is that the procedures are attached to them that can access and modify the object's data field. So this information is very valuable. This information is very valuable for beginner level because you need strong command on object oriented programming. Structured programming is another paradigm that is aimed for improving the clarity, quality, and development time of programming, computer programming, and by making extensive use of structured control flow. Structured control flow like if and then else, then some repetition flow like while, for, and various type of block structure. This programming make the solution faster. Okay, and another is functional programming paradigm. It is another programming paradigm that applies composition of function. There are some functions available which is called built-in function that comes with your programming language. There are some functions called the user-defined function. These are generally written by the programmer. So it is a directive programming paradigm in which functions are in tree of expressions that maps value to other values, rather than a sequence of imperative statement which update the running state of the program. So all those concepts are confusing. If you find these concepts are confusing, no, don't worry, it will take a little bit of time and then you can understand. Just try to understand what is Python. Now we understand this. It is a object oriented programming language, high level programming language, and you can use its functions and module for solving problem. Where you can use these, I think that is the point we are going to discuss next. Let us try to explain a roadmap of learning Python so that we can understand that how to complete this journey. Number one, first of all, an introduction is very important, and I think I have given you some introduction. This knowledge is sufficient for any interview relevant to this skill, and now you can tell your employer that I know what is that. Okay, so introduction part is very important. Then in the next part we need to understand reason why we need this skill, where we can apply this. These 2 points are very important. Again and again, if you study a skill, then you can learn where you can apply this. But before that, if you get some idea that I'm going to use this tool for this purpose and this is going to happen if I learn it well, then it is an inspiration, it is a motivation for the learner. So that is the point that I want to discuss in this small video, because you know what, it is not possible to complete everything in just one video. We have to divide in various segments. So what is the upcoming segment, how you can learn this, and this is the point I am going to learn. First of all, understanding the few example. Just I will study some basic code and try to understand what does it mean. We'll try to understand each step. That is the first procedure of learning it. Then okay, we can discuss about the history of this programming language, because this is our interest. It is not going to help us improving our skill, so it is auxiliary. We can discuss many things about history, where it is used and how it was used. Okay, Important thing is understanding an editor or IDE that is going to help you in coding. Okay, you can use Visual Code, you can use PyCharm. There are different type of IDEs available, and we'll explore this. Then what is the program structure? Program structure means understanding the statement, then comments, and then indentation, what type of indentation is required for this particular programming. So these concepts are essential, like understanding data types. Okay, then the next area of knowledge will be like exceptions, errors. When your compiler is throwing some error, understanding this error, how to use operators, control characters, common functions. These are very important. Then once this is clear, the next step will be understanding the repetitions and conditions or choices, like if else, then for, while, what is control statement, how to use this, how to use various type of relational operator, how to use some loop, and getting some confident on those topics. These are important. The next topics are like dealing with arrays. What is array? We already know it if we have some previous programming knowledge using C or PHP or JavaScript, because array is a concept which is common in all those programming language. If you don't have knowledge about this, no problem, we can discuss it from beginning. Understanding Python list, then troops, or understanding the dictionaries. These are new concept coming in Python that are generally in a different form in other programming language. Okay, the next thing is dealing with function. There are some inbuilt function there. You can also define some functions, and there are recursions, not recurrence, recursions are dealing with errors and exceptions when you are dealing with some input and output, like input and output of files. And generally using Python, you deals with different type of files, and opening this file, reading this content, then using this content, doing something else. These are part of a programmer day-to-day activities, and we are going to understand this from the lessons. Then I have already discussed about what is object and class, method. These are three major pillars of object-oriented programming: understanding what is object, what is classes and methods, and how to use them in Python object-oriented programming. This will be the next that will be the next stage of understanding. There are some built-in function in Python, how to use this built-in function, how to access the attributes and methods of Python. These are the advanced stage of using functions, string-based functions, and then dealing with some module, some standard library, or called the packages of Python. So packages are set of programs that are already there. You can use plug and play this code for solving some complex problem. Then with that knowledge, you are able to develop your own project. You can develop something unique as a problem solving, and it may be data science related project or software development project. And with this advanced knowledge of programming, Python programming knowledge, you can do data visualization, you can analyze data, and there are various type of programs available that is essential for data science, machine learning, and artificial intelligence, like Panda, NumPy. Okay, so dear guys, this journey is going to be very interesting. I'm not using too many slides, instead trying to transfer the knowledge relevant to this particular skill set one more time. It is a repeat of these discussion. First of all, Python is an object-oriented high-level programming language. It was developed by Guido Rossum in 1989, in between 1989 to 81. So it is almost 30 years old programming language. The programming language is easy to learn compared to other language like C, C++, or PHP, and etc. So if you already have some basic idea of a programming language, that is good. If you don't have any idea of other programming language, you can also learn Python. All the tech giants, major tech giants, especially Google, YouTube, BitTorrent, and NASA use this programming language. So you open the door of a lot of opportunity in machine learning, natural language processing, neural network, and artificial intelligence, because all those fields use this particular programming language and it opens doors of many other fields of computer science. So there are some major characteristics of Python. Python is a very high level programming language but easy to learn, and it is open source. You don't need to pay a penny for using this software. It is absolutely free, and you can download and install it on any device. Once you are writing some code on Mac, this code will run on other other operating system like Windows and Linux. If you write something in Linux, it will work in other too. So it is environment independent. And one more thing is that there are various type of libraries available. Using those libraries, you can add additional function to your software, and these libraries are also platform independent. That means you can use the same library in different coding environment. Okay, so dear friend, here I think from this discussion you understood what is Python, why learning Python is important. One more bonus question that I want to discuss here. What is it? What is the benefit of using Python in data science? Of course, if you are looking for data science career, and it is one of the most important lucrative career for any beginner level IT enthusiast or who wants to enter into the information technology industry, learning Python will definitely gives you these additional skill for making a great career. And it is the best language for data scientist. Why? Because number one, data scientists use various type of softwares like TensorFlow, NumPy, Pandas. These are actually Python friendly. You can use Matplotlib, which is a software that creates stunning, effective data visualization, and data visualization is a part of data science. Pandas is one of the most widely used favorite library of data science, and here you also need Python. So Python support multi-paradigm programming. And what are these paradigms? Like procedural, object-oriented, or functional, and or combine of all these paradigms. So what is computer paradigm? We'll discuss it in a later chapter. And then you can incorporate dynamic data type, which is dynamic means you just need to declare x is equal to 10. That's it. You don't need to declare it like int x is equal to 10, where you are specifying what type of data it is, because Python can understand what is the data type from the declaration. So it is fast, and then there are so many benefit of this programming that using few lines of code you can solve many problem, and that's why you must need this skill. Hope you understand the introduction of Python from this class. If you like this video, please continue watching the upcoming episodes and subscribe the channel. Thank you and see you in another class. Hello friends, hope you are doing well. I'm Narayan. This is class number 2 on Python. If you have watched class number 1, then this chapter is going to be helpful for you in understanding Python programming language. Before discussing about Python programming language, let's discuss a little bit about what is program and how a programmer think. Programmers are actually everywhere. You can see that mathematicians are then statistician, computer scientist, all branches use computer programming. In this chapter, I am going to discuss how to think like a programmer. Programming is used in mathematics, it is used in engineering, in natural science related experiment, everywhere. So let us take example of an engineer who solve a problem using mathematical solution, device-based solution. So when you design something, you assemble all the parts together and evaluate that we can use some alternative as a trade-off and we can fix it. Just take example of Bill Gates, who developed programming for Windows, and then he purchased the software Microsoft from a software developer at a cost of 50,000, and then this software is become a solution for personal computing. Okay, so do not think too much, just think as simple as possible. For example, a scientist who is experimenting on some molecule and he has a hypothesis that this molecule can eradicate a particular disease. Then based on this hypothesis, he performs some sort of experiment and he tests those predictions. So programming is very helpful for solving a problem that can be that can be solved using logical and mathematical activities, mathematical operations. Here, problem solving means the ability to formulate the problem and think for the solution, and these formulations are some step-by-step process. For example, when you are watching this video is actually running based on the program, and this program is executing this content. So when we use some app or a website or a web application, behind the scene a program is running. Okay, so you need to think like a programmer before learning any programming language. I am going to discuss here how to think like a programmer. So what is program? A program is a sequence of instruction that perform specific computation tasks. So program is a set of instruction that is given using some programming language, and computer can follow those instructions for solving a problem. So in any sort of computation, you will find there is some mathematical operations are used, mathematical expressions are used for solving this. Just think, if you have done a little bit of math in your school days, like finding the roots of a polynomial, and in that you get a algebraic expression, and then use various type of formula, and step by step you find the roots of a polynomial very easily. And sometimes we plot the information in a graph, and we draw some nice parabola or circle from a equation using coordinate geometry. So we solved a little bit of mathematics in our school days where we followed some steps. Programming is similar kind of things here. You use different kind of language for solving a problem. Here some parts are common in all sort of programming. These parts are: number one, the input means a user inputs some information through keyboard, maybe as a file or as a value, or some network, or some input from a device. So input is very important. Input is not just the value of x is equal to 10, not like this. Input may be a file, input may be some response from a device, etc. What is output? Output may that you want to see on the screen after processing, and it send over network, or it is just a file, or it is an output on the display unit. So just upgrade your thinking from the fourth grade or fifth grade understanding of computing. Just improve it like this. The input may be just a file, maybe just a response from a device, or output is not just only the visual that we see on the monitor. It may be a file, it may be a response through a network. Okay, maths is very important part. That means there will be some mathematical operation involved in this programming. It may be addition, subtraction, multiplication, or other operators like mod and etc. And you will need to use some conditional statements, and these conditional statements are generally if else. If this condition true, then this will happen. If this condition is not true, then another expression will show the result, something like this. Some conditional formatting, conditional loops, these. And there is some repetitions are some tasks that are performed repeatedly using code. So just like counting something, like counting all odd numbers or all even numbers, this is possible using some repetition. This repetition may be for, while, do while, etc. So believe it or not, it is pretty much same in all programming language. The logic is pretty much same in all programming language. Only difference is the syntax. So every program you use, it doesn't matter whether you are using a very high level program or a or program like Python, you need to use the same concepts. You can think of programming as a process of breaking a large task into small pieces of small tasks. Okay, so suppose you are building a pyramid, but whole pyramid is not built in just one day. It is built one by one. Or just for take example of making a cup of tea. Making a cup of tea has several steps involved, like boiling water, then adding some sugar and tea leaves, and then filtering that extract, then serving that tree. There are various steps involved, you can understand. As a beginner, how to start writing a Python program? You can install Python on your Windows or Mac PC or in Linux PC. You will find the exe file, download it and install it. It is very simple. Once you install it on your PC, you will get a default IDE about this programming. That means IDE means where you can write the program directly. But if you don't know how to install Python, then wait. It is just for example, after installing Python, you will get an IDE like this, where you can start writing your code. Like the first line of code is like print within parentheses. First we write hello world, parenthesis close, and the output is hello world. Now if you have not installed Python and you don't know how to install, wait, because in the next part of the video we'll show you how to install it and all those things. You can use some website that provide you the online user interface for the programming, like Anywhere Python is a nice website. So just create an account, and then you can get an online programming. Here you can do the same programming like print hello world. So it is an online programming from IDE. So this is a little bit challenging for someone who is going to learn it for the first time. So if you are familiar with this interface, then you can install command line interface on your PC. For the beginner, I suggest you can create an account on website like Anywhere, Python Anywhere. There are many other websites available for the similar purpose. So once you installed, once you are opening this Python actually interpret your programming code into interpret, and it process according to the instruction. So in a IDE you will find few lines. First you will see few lines here like Python 3.0 3.11.1. this means the Python version, and it is running on Windows PC, so Win32. And by typing help, copyright and credit and license, you can get more information about this software. So dear friend, here this when I'm shooting this video or recording this video, the latest Python version is 3.11. maybe in future when you are viewing this video, you will get there will be some new version, but the old version is sufficient for learning. The last line is a prompt. So this triple greater than sign is a prompt that indicate that the interpreter is ready for entering the code. So you can see the same prompt on online version as well. So if you have not installed it on your PC, then you can use this Anywhere website, create an account, and you can get an IDE like this. And if you have installed it, then you can use your own version that is running on your PC. Okay, so here we can check whether they are working for any mathematical operation, like 1 plus 1 is equal to 2. So it is just like a calculator. 5 plus 10 is 15. Simple. You can do other mathematical operations like plus, minus, then multiplying something. Like I can do a very big maths here, 100 into this asterisk sign into 6,000. Very simple. For example, 7, this sign is 5. Divide sign is like this, 7 divided 3, 2.3335. This sign is called the XOR sign, exponentials. So there are many mathematical operators that we can use on Python. These are very easy. You can also check the type of a data, like just type. The type of the variable is very important. Understanding what is the type of the variable. A value may be a floating number, maybe an integer, or maybe a string. So if you want to know about the type of this value, just write type and place the number. It is an integer. Similarly, if I type something like 4.5, it is a float. If you want to clear the screen, the command is Control L. It will clear the screen. If you write something, type say hello, single quotation, close, and it shows it's a string. This is how you can find the type of a value. When you type a large integer, you might be tempted to use the command between a group of digits, and it is not a legal integer in Python. So like for example, if you type something like this 1 comma 0 0 0 comma 0 0, so although it is an integer, but Python will show some error. So this is a kind of type error. We'll discuss about error in the future class. So at this moment, you just understand that this is not an integer. What is the difference between formal and natural language? Natural languages are the language that people speak, like English, Spanish, French, Hindi, Bengali, and they are not designed by people. They are evolved naturally. That means for a long time, when people are using different language developed automatically day by day. Formal language are the language that are designed by people for specific applications. For example, the notations that mathematicians use in a formal language that are designed by people and that denote some relationship among the number and symbol. Similarly, you can see in chemistry, chemists also develop some representational structure for showing some chemical formula that shows two molecule react with each other and produce another product, and that is also written using formula. So these kind of language are formal language. So programming language are formal language. These are not developed by naturally. These are not developed, people developed them. So we'll need to understand their syntax for the better use. Formal language tends to be strict according to the syntax rule. If you make some sort of mistake during typing or adding some information, then it will show an error, and that error is helpful for fixing the bug. For example, in mathematics, if you write 3 plus 3 is equal to 6, that is a correct sentence. That is a correct syntax. That means 3 and 3 is equal to 6. But if you write something like 3 plus equal to 6 $3, that doesn't mean anything, because according to the syntax that expression is not correct. Similarly, in chemistry, if you write H2O, it will mean a particular substance, but if you write something 2HOO, it will mean nothing, because it is not actually written as per the syntax. Syntax rules is very important. That's why, because without proper syntax, the information is not meaningful for the person or the device. Okay, so you use some sort of operator and symbols for writing your coding. And second type of syntax rule is actually based on English language. In English language, there is a full stop at the end of a sentence. That means a sentence is making a full sense and full meaning. Similarly, in programming, you have expression lines of code, and one lines must be related to one instruction or one command. So a well structured English article is meaningful. Similarly, a well structured programming language is meaningful for all the programmers. In this part, we will be familiar with some vocabularies that generally used by programming uh, languages. First of all, what is ambiguity? Natural languages are full of ambiguity, which people deals with by using contextual clue and other informations. So formal languages are designed to be nearly or completely unambiguous, which means that any statement has exactly one meaning, and it is regardless of the context. Okay. So what is redundancy? In order to make up for ambiguity and reduce misunderstanding, natural language employs a lot of redundancy. When I am talking about this particular concept, I am doing this again and again, so that I want to transfer a concept to my students. So as a result, they are often verbose, and formal language are less redundant and more conscious. And another is literalness. Natural languages are full of idiom and metaphors. When we talk, we use various type of metaphors, and when for example it is raining, like cats and dogs, so here cat and dog is not present in this language, but we use it as a idioms for expressing the heaviness of the rainfall. But in formal language, you cannot use this kind of idioms. Here in this case, all are formal. So if I say the penny dropped, there is probably no penny, and rather than and nothing is dropping here. This idiom means something else. Okay. But it is a little bit confusing for someone who is new to this culture, who is not familiar with this program, with this particular language. In formal language, every line should be exactly mean one meaning. It is universal for all the people who is understanding this. So this is computer programming. Computer programming is built using formal technique. So because we all grow up speaking natural language, so it is a little bit difficult for us to understand or write everything in formal way. So the difference between formal and natural language is like difference between poetry and prose. When you read some poetry of great author, you see that the great poet, you will see that the poet used different word together in one line for meaning something else, which is completely completely different from the exact meaning of the word. So words are used for their sounds as well as for their meaning, and the whole poem together creates an effect of emotion in your mind. And this is the ambiguity is not only common but often deliberate. Whereas in the prose or essay, we see that the literal meaning of the word is more important, and the structure is more meaningful, and prose are more analysis type of thing, and it has it, and you can understand all line from the prose. So computer programs is unambiguous and literal. That means it can be understood easily by analyzing of the tokens and structure that are used in this program. Okay. And now we understand the formal language are more dense than the natural language, so it takes a longer time to read them, and the structure is very important here. And we also understand that a small error like a spelling mistake or a syntax error will definitely change the meaning of the program, and this is why we see a lot of bugs when we write a coding using proper syntax and logic, because at the learning stage we make mistakes during our coding. Now, how to debug them, that is very important, because the interpreter is not understanding some part of your program and it is throwing some error. So programmers make mistakes, and debugging is a process through which you can solve this problem. So programming errors are called bugs. So it is again a literally meaning is that there is something which is actually uh, distracting the actual flow of the program, and that is kind of a bug. So the process of tracking these bugs is called tracking, and eliminating these bugs is called debugging. And the programmers especially use this debugging technique for making the program more strong and error free. Some bugs are easy and you can easily fix them. Some bugs are difficult, you need more time to fix them. So when you work on some coding, bugs are very common, and as long as you are clear about all the previous step, you can find a solution about the bug. Okay, so what is the main job of a program? The main job of a programmer is to make his coding error free or bugs free. Now we, in this particular class, we have used a very little number of slides, but our main goal is to make you clear about the problem solving process, and this process is formulated based on some solution. And we also explain the high level language, what is high level language, what is low level language, what is formal language. So Python is a high level language and is just like human language. You can read and write Python program. That means if you just read the program, you can understand the logic. Then it has an interpreter. So what is interpreter? Interpreter is just like another program that can read your program and it can execute for the system. We understand what is prompt. Prompt is actually the input area where your program takes some information from the user and then it process. We understand the program. What is program? Is a set of instruction that is written using proper syntax for solving specific tasks. We also learn what is the use of operators, how to find the type of a value just using type function. We also discuss different type of data like integer, floating number, string, natural language, formal language. And natural language is any language that people speak normally, and we also understand what is formal language. We understand what is token. Token is one of the basic element of syntax structure of a program and analogous to a word in a natural language. Okay, so what is syntax? Syntax is the rules that govern the structural program. We understand what is bug. Bug is an error, and we also understand what is debug. So from this discussion we learned all those things. See you guys in the next episode. One of the most powerful feature of programming language is the ability to manipulate variables. A variable is a very common concept in any programming language. For example, let's start with this particular example. Here width is equal to 20 is an assignment statement. An assignment statement creates a new variable and gives it a value. So width is equal to 20 means width is a variable and its value is 20. 20 is an integer, and we can assign any value to a variable name, like name is equal to Narayan. Narayan is a value and name is the variable name. A common way to represent variables on a particular program is like a statement. So when you are drawing something as a flow diagram, and you use variable as in the input, you can use a rectangle box. Programmers generally choose name of their variable in a meaningful way, so that when in future someone else reading this program can understand the purpose of using this name. Variable names can be anything, and program to program it's change, but in Python you can use any name as any name as variable name. But there is a little bit information that you have to remember. The underscore character can appear in a name. It is often used in names with multiple words. Like when you want to make it meaningful, you can use this underscore for connecting words. So this is very common in any programming language when you are using the similar kind of programming language. So if you give a variable a meaningful name, it will be helpful for next phase of the project. Some names are illegal name. That means if you use some keyword as name, then it will be invalid. For example, you cannot use the keyword class as variable name because it is a key, and this particular word is used for some purpose. So dear guys, let's start understand what is keywords. There are some major keywords available in Python, like true, false, then if, else, then yield, while, not, or, is, return, none, and, as, and if. So these keywords are essential. These keywords are reserved for specific purpose. Now, how to write an expression? When you are going to write an expression, it is a combination of value, variable, and operator. A value itself considered as an expression. So for example, when you write n plus 25, it is a kind of expression. When you type an expression in the prompt, in the Python prompt, the interpreters evaluate it when you press the enter button. Very simple. Let me show you. I'm opening Python program, Python's IDE tutorial on Python. It is an introduction course on Python. So in the previous 3 classes, we have discussed about what is Python, what is the benefit of using Python, and we also discuss the various uses of this programming language. Today we will discuss more about the variable, string, and function. So it is class number 3. If you are new to this class, then I recommend please go through the previous 3 classes. That will benefit you more. I have also created one class on what is program. If you are non-technical, you are from non-technical background, then don't worry, you can also learn Python. So let's start today's class. Functions. In the context of programming, a function is a name of a sequential statement and it performs computation. So we can consider function as a small part of your program. When you define function, you specify the name and the sequence of statements, and when you call the function, you use its name. So we call the function by its name. We have already seen the use of function in the previous classes. For example, type. When we write type and within parentheses we input a value, maybe it is an integer or a floating number, we can see that the type of this value is displayed. So type is a function, and this expression means that you are inputting one argument in this function and it is showing you the results. So this concept is very clear. Python provides functions that convert a value from one type to another type, so we can use that function for converting data types. For example, if we write int int and within parentheses if we import a floating number, it will display us the integer part of this number. Again, if we input some integer inside of a function like float, float float as an argument, this function will convert the integer into a float number. So let's see how it works using our Python IDE. There are different types of functions available. Python has a math module that provides most of the familiar mathematical functions. A module is a file that contains a collection of related functions. So when you import this module to your program, you are including those functions in your program. So before we can use function in a module, we have to import it as an import statement. And how to add this import statement? Like write import math. This statement creates a module objects named math. If you display the module object, you get some information about it. So how to do this? Just write import and math. Okay, now if we write math, it will show that the module math is included and it is inbuilt. The module object contains the functions and variable defined in this module. To access one of the function, you have to specify the name of the module and the name of the function separated by a dot, and it is known as the dot notation. So how to use it? We will use one example here. Look at the example on the screen. In the first statement, we have declared the value of radians is equal to 0.75, and then height is equal to calculated as math.sine radian. So math sine is a function, default function inbuilt is in math module, and we are just inputting the value of radian variable. So we find the sine of radians here. The variable name is radians is a hint that the sine and the other trigonometric function cos, tangent, etc. Take argument in radians. To convert from degrees to radians, divide by 180 and multiply by pi. So we know this formula and we can apply this here as well. In this example, math.pi gets the variable pi from the math module. The value is a floating points approximate of pi, accurate to about 15 digit or more. So far we have discussed about variable, expression and statement. So now we can define some function. One of the most useful feature of programming language is their ability to take small building blocks and compose them. So for example, the argument of a function can be any kind of expression, including arithmetic operations. So in the previous example, we have seen some expressions and that are mathematical, and it is giving us the result based on the expression. So almost anywhere you can put a value, you can put an arbitrary expression with an exceptions. The left side of the argument statement has to be a variable name, and the right side of the statement can be an expression, a value. So if you write something as an expression on the left side, then it will throw some syntax error. For example, cannot assign two operators. So let's see how it is actually what I'm trying to say here. Like for example, we can write something x is equal to say hour into 60. So the value of x is not mentioned earlier, but it was a right statement. From statement wise it was not wrong. But if you write something just opposite, like hour is not defined earlier, suppose we are defining hour is equal to say 5, then we can calculate. Now if we write the same thing, the value of x is right now 5 into 60, 300. Print x, it is 300. But if you write something just opposite, like days, although I am defining days value is like 7, and then we are writing something days into 24 is equal to say time. Suppose time is a new variable we are going to define now. Is it visible? Just trying to, okay, it will show a syntax error because this is not the right way. This is showing a syntax error. If we write just opposite, time is equal to days into 24, then it is fine. It is not showing any error. So you have to place the variable name on the left side. So how to add a new function? We are going to learn this. Before discussing that, I want to discuss a few glossaries or few items. I want to define vocabularies here so that it is not difficult to understand. First of all, function. What is function? Function is a name, a sequence of named sequence of statement that perform some specific operation. Functions may or may not take arguments and may or may not proceed a result. That means you can write a function without taking any argument. Okay. Now what is argument? Argument is a value that you pass through a value that you input in a function. So a value provided to a function when the function is called, and this value is assigned to corresponding parameters in the function. Now what is the body of the function? Body of the function means what you write inside the function definition. Okay, it is the sequence of statement. And what is parameter? Parameter means a name used inside a function to refer the value passes as an argument. And what is function call? Function call means a statement that runs the function. It consists of the function name followed by an argument list within a parenthesis. So we have already understood how to use that. For example, like type, and if we want to check the type of this time, then we can see it is an integer. Okay. Now what is fruitful function? A function that results a value is a fruitful function. Sometimes a function has no result, then it is a void function. And what is import statement? We already understand that import statement is a statement that read a module file and create a module object. Did we use this import statement in this particular program? Yes, we have used like import math. Okay. And then what is module objective? Module objective is a value created by an import statement and provide access to the values defined in a module. And what is dot notation? We also learned this dot notation, the syntax for calling a function in another module by specifying the modular name followed by a dot or a period in the function name. Did we use these today? Yes. For example, math.sign, we use the dot notation here. What is composition? Composition means using an expression as a part of a large expression or a statement as a part of a large statement. Flow of execution means the order statement running. Then what is void function? A function that always return none is a void function. And other points are like module. Module is a file that contain collection of related functions and other definitions. Now we are familiar with a lot of vocabularies. Now if we discuss this point in details, there will be no issue in understanding them. Now my dear friends, let's try to understand how to define a new function. So far we have used some function, and those are default function. A function definition specify the name of a new function and the sequential statement that runs when the function is called. So here we have an example on the screen, and we can see that we have defined a function fib for Fibonacci series for printing some number that are in Fibonacci series. So Fibonacci is a popular mathematical series. It's a collection of number like 1, 1, 2, 3, 5, 8, 13, something like this. Okay, and if we want to display all the number till 2000, it will display using this function. So here we have defined this function. How to define this function? Just look at this statements. Okay, so the keyword diff is the starting point of defining a new function. So def, sorry, not diff, def is a key word that indicates that is a function definition. So after def we have used a word like fib, and this is the name of the function. The rules for function names are same as the rules for variable names. That means you can use letters, numbers, underscore, anything that legal as a function name. What is not legal? Like if you use some special character, then it will not work. You cannot use a keyword as a function name like class, or you cannot define dif as a function because def as a function because def is a keyword. The empty parenthesis after the name indicate that this function is not taking any argument. But here we seen that we are not using an empty parenthesis. Instead we are using a variable n. So n is the argument. Okay, so first line of the function defined the header of the function, and the rest part of the function is called the body of the function. The header has to be end with a colon. So you can see the colon sign here. So colon is very important. If you forget to place this colon, it will show an error. Then you have to add some indentation here. Here Python is little different than compared to JavaScript and other PHP program. So in other PHP program, indentation doesn't matter, but here you have to use some indentation. All the quotation mark, single and double, must be straight quote, usually located next to enter on the keyword. Here in this particular program, we have defined we have a statement a comma b 0 comma 1. If you type function definition in interactive mode, on the interpreter print ... to let you know that the definition isn't complete. So we use ... for 3 dots for showing that the definition is not yet complete. Okay, so now we understood what is parameter and argument. Inside a function, the argument are assigned to variables called parameters. So here in this function, we see that there are some variables are used a and b. When we create a variable inside a function, it is local, which means that it is only exist inside the function, and the function takes the argument. Here n is the argument, and based on that it is doing the calculation. We can see there is a while function is used, and the while statement is used, and the while statement is actually doing an iteration and checking the value of b compared to n and printing b, and at the end it is adding a space, and this is how actually we can see the printout of Fibonacci series. And for understanding the flow, we need a little bit more understanding of this while statement, but here we are talking about the function. So this function is a fruitful function. That means it has a return value. Sometimes functions has no return value. Those functions are called void function. So when you call a fruitful function, you almost always want to do something with the result. So we can reuse the function again and again for more calculation. So for example, here we can print the Fibonacci series up to 2000, up to 10,000, and any number. But here void function might display something on the screen or have some other effect, but they don't have a return value. If you assign the result to a variable, you will get a special value called none. Okay, so dear friend, now we are going to discuss about why function is required. What is the importance of function? It may be clear why it is so worthy. From the discussion we can reuse the same function again and again, but the major benefit of functions are as follows. Number one, creating a new function gives you the opportunity to name a group of statements, which can makes the program easier, and you can read and debug particular section when a particular function is not working. Okay, so functions can make a program smaller because it eliminates the repetitive code. Later, if you make some changes, you can only do changes on the particular function. Dividing a long function into small parts allows you to focus on a particular area of the business requirement or process, then assemble them into a working whole. So this is a kind of thinking which is very helpful for programmers for solving complex problems. Well-designed functions are often useful for more program. That means you can reuse this function in other program as well. Once you write it and debug it well, you can reuse it. Now, what is the debugging process? One of the most important skill of any programmer is debugging. Debugging is like some detective work. Like you can find some clue, and you can confront some challenges and try to solve it using some clues. And debugging is also like an experimental science. Like you have some idea, and then that idea is not working as per logic, then you correct your ideas. And if you have some hypothesis kind of thing, you can correct it during the testing. So I have created a video on that, what is program, and I have defined the importance as well. Dear friends, I think from this discussion we understood what is function in Python programming. In the next episode we'll discuss more about Python. Hello and welcome to another episode of Deep Learning, and today we are going to discuss about image classification using convolutional neural network. So it is going to be a discussion on the basics of how to use convolutional network, different types of concept relevant to this, and later we'll also see some code and how to implement it on a dataset. So today we are going to use CIFR 10 dataset. It is free and you can utilize in your project. So it is a collection of around 65,000 images of different objects like frog, cat, deer, airplane, truck, etc. So the major goal is to use the convolutional neural network for classifying these images. So let's start. But before starting the coding about this project, and we want to clarify some background relevant to deep learning. You already watched a video in this channel about the deep learning bootcamp, so you can also check this for elementary understanding. So this is a little bit advanced level, so if you have already watched the first video, then it will be helpful for you. So you will get the link of this first video somewhere in the description below. So let's begin. Let's move to our first slide. So what is convolutional neural network? In short, we use the abbreviation CNN. So CNNs are a class of deep learning models specifically designed for processing and analyzing visual data such as images and videos. So visual data are different from numerical data, right? And the process that you use for numerical data are not suitable for non-linear data such as image and text. So these particular neural network, convolutional neural network or CNN, are widely used in computer visions such as image recognition or image classification, object detection, and image segmentation, and many more. So dear friend, we can use this convolutional network for classifying the images. The key idea behind CNN is automatically learn hierarchical representation of the input data by using convolutional layers and pooling layer. Now, what is convolutional layer? What is pooling layer? We'll discuss these one by one. And these layers, in deep learning, there is one input layer, there are several hidden layer, and then you get the output layer. So here inside the hidden layer, you have convolutional layer, you have pooling layer, and these layer allow the network to efficiently detect local patterns and features in the input, and also reduce the computational complexity and the number of parameter in the model. So in the next slide, we'll see a simple diagram for understanding these convolutional layers and pooling layers. So let's move to our next slide. In the next slide, we see the fundamental component of the convolutional neural network consist of some input layer, convolutional layers, and some pooling layers. You have some fully connected layers, and then the output layer you can see in this particular diagram. So here we see that the convolutional layers has a very significant role in this whole process. Convolutional layers apply some filters, and these filter to the input and to extract specific feature. Why they use this filter? Because this filter can extract some specific features from the images, and these filters slides or layers over the entire input images, and computes the dot product of different locations. So where these kind of pixels are there that are similar, so it is an operation results of feature mapping. This is called feature mapping, finding out the features from the image, and it highlights the presence of different patterns and features in the input data. So you suppose you are inputting a lot of cats images, so it will find the feature of cats, like cat's eye, in all the cats related features, and it will find this pattern. And these filters are learning during the training process. When you are inputting a lot of training data, it is actually learning from this training data and allowing the network to automatically detect relevant patterns. So it finds some relevant patterns from the training data. So everything is going behind the scene. You cannot see this when you are running this code, but you need the concept that what is the function of convolutional layers. Then you have some activation function. So activation function is a very important concept in deep learning. After each convolutional operation, an active function is applied element wise to introduce the non-linearity in the network. So some commonly used, there are different type of activation functions are available. We'll discuss different type of activation function in a later slide, but here you just try to understand that the most popular activation function that is used is called rectified linear unit, or ReLU, which is a set of negative value to 0, which set the negative values to 0 and positive value unchanged. So after doing this filter, we get only positive values, all the negative values are removed, and the non-linearity enables the networks to learn complex relationship and make the model more expressive. So next is the pooling layer. So pooling layers perform downsampling on the feature map, and selecting a representative value from a small region like 2 cross 2 as an input. And the most common pooling operation is max pooling. So max pooling is a ready to use function for adding some pooling layers, which takes the maximum value of a region. So when it is selecting a small layer, small 2 cross 2 layer from the picture, it is taking the max value, and pooling reduce the spatial dimensions and makes the network more computational efficiently and robust to transition in the input. Now the next layer is fully connected. You can see the fully connected layers, and it is just before the output layer. So after several convolutional and pooling layers, you don't know how many convolutional layers behind that it is working and how many pooling layers are the resulting the feature map. So feature map and flattened into 1D vectors. So 1D vector is a type of data. The vector is then passes through fully connected layers and which perform traditional neural network operation, and these layers combine the learning feature learned feature, so all the features that are learned from the previous layers make some sort of decision. This is helping them for making decision, and the output layer shows this decision. Here another concept is called the loss function. The loss function is used to measure the differences between the predictive output and the target level during the training. So from classification tasks, the commonly used loss functions include softmax, and we'll use softmax in the example you will see, and this include softmax cross entropy for multi-class classification and binary cross entropy for binary classification. The learning process of a convolutional neural network involves forward propagations, where the input data passes through layers to generate predictions, and backward propagation. What is backward propagation? In backward propagation, the model learn from the errors and update the weight of the filters to minimize the loss function. So the convolutional neural networks have demonstrate exceptional performance in wide range of computer vision related tasks, and it is really significant and contributing a lot in the advancement of this computer vision related field. And using that, you can do object detection and image generation and etc. So we understood some fundamental component of convolutional neural network. Let's try to understand a package right now, because different type of packages are machine learning packages or libraries are useful for doing these projects. So the most useful machine learning library, you can guess, it is TensorFlow. So what is TensorFlow? Let's try to understand it from the next slide. So TensorFlow is an open source machine learning library developed by Google Brain team, and it is one of the most popular and widely used deep learning framework, and that allows developers and researchers to build and train machine learning models efficiently. So dear friend, TensorFlow provides a flexible and comprehensive ecosystem for various tasks, including numerical computation and data flow graphs, automatic differentiations of gradient based optimization, etc. So let's see what are the features of TensorFlow. When you learn more about features of TensorFlow, you can utilize this tool in a better way. So the next slide shows the features of TensorFlow. The major features are symbolic computation. TensorFlow use symbolic computation graphs, where data flows through nodes represented by tensors, and these graphs enable parallel and distributed processing, making TensorFlow suitable for high performance computation. Now it has a very significant part in deep learning. TensorFlow is particularly well suited for building and training deep learning models, and that include artificial neural network, convolutional neural network, recurrent neural network, so and many more. And it has flexibility offer for high level API like Keras. We'll use Keras in the example project, and it is easier for modeling and abstractions, as well as low level APIs are useful for fine grinding the control over the model architectures and training process. It has the portability. What portability here, by portability we means that TensorFlow support various hardware platform such as CPUs, GPUs and TPU. TPU means tensor processing units, make it versatile, and researcher and developers are capable to run it efficiently on different devices. It has the scalability. It support distribution computation, allowing user to distribute model training across multiple devices and machines, and it is well suited for large scale machine learning tasks. Then you get a large community of ecosystem around the world who are contributing on the forums and support group, and there are numerous pre-trained models available, tools are available, so you get plenty of resources for building your next machine learning model or deep learning model. You can easily integrate the TensorFlow, and the integration is seamless. You can add various other libraries that support TensorFlow and that leverage the programming, and you can make your code more advanced and efficient. So the deployment is easy. TensorFlow can be exported in various format, including mobile device and web, making it easy to deploy machine learning model in a wide variety of real world applications. So TensorFlow has been used extensively in a wide range of applications such as computer vision, natural language processing, speech recognition, recommendation system, and image recognition as well. So it has the popularity that it is one of the strongest machine learning community, and TensorFlow has played a significant role in the advancement of machine learning and has contributed by various developer and researchers. So we understood the key features of TensorFlow. Let's move to the next tool that is important for this project, is this Jupyter Notebook. I think you are already familiar with Jupyter Notebook. Just for understanding what is Jupyter Notebook, it is an open source web-based application, and it allows user to create and share documents that contain live code, equations, visualization, and narrative text. And Jupyter Notebook is open source. You can easily download it, and you can share live code, equation, and visualization. Originally this software was known as IPython Notebook, but later it is changed to Jupyter Notebook, and it support Python, R, Julia, and different type of coding, and the name Jupyter is a combination of the popular programming language Julia, Python, and R. Okay, so we understood Jupyter Notebook. Let's see its major feature. Number one feature is interactive computing. Jupyter Notebook provides an interactive computing environment, enabling user to run code cell individually, and you can see the result immediately. So in the first cell you are typing the code, and the next cell you can see the output just by clicking the run button. You can run a particular cell. So code execution is very easy. User can write and execute code say in separate code cells, and the output such as print statement and visualization is easily displayed on the same page. It has the rich text support, so you can use markdown cell for giving a description about the tasks you have done. So the commenting process is very simple. You can add various type of comments that are relevant to your code. Data visualization is easy. Jupyter Notebook is integrated to different type of data visualization library like Matplotlib, Seaborn, and Plotly, and that's enable you to see the output in the form of a graph on the same page of this web application. So we understood the various feature of Jupyter Notebook from this slide. Next we see that what are the additional features of this notebook. We can do data exploration. The Jupyter Notebook facilitates data exploration and analysis by allowing the user to interact with data platforms, calculation, and visual results in real time, and they can see the visual results in real time. Integration with data science library. You can add different type of data science library using some import command, and you can use NumPy, SciPy, Scikit-learn, TensorFlow. So Jupyter Notebook is friendly with various types of data science and machine learning workflow, and that's why the seamless integration make it more popular among the developer and researcher. It has collaboration and sharing features, so notebook can be easily shared with a group of developer and researcher, and user can share notebook via email and GitHub, and this is why it is so popular. It also has the kernel support. Different type of kernel language are supported by Jupyter Notebook. Each notebook runs a specific kernel that interprets and executes code in the respective language. For education and teaching, it is very helpful because it is free, open source. Jupyter Notebook has gained widespread of popularity among the data scientists, researcher, educators, students, and developers, and because of its versatility, interactivity, and visualization capability, documentation capability, etc. So it is an essential tool. You can download it free from the website. You can search Jupyter Notebook download in Google. You can find the website link, and if you install Anaconda as a Python library, you get this particular tool. So I will use Anaconda for this. So let's move to Jupyter Notebook installation and this process. Dear friend, when you install Anaconda, you get a link here, Jupyter Notebook. Just clicking the launch button, you can launch the Jupyter Notebook. It will open a page like this, localhost/3, and this URL. You can see the folder of your PC. Here is a data set of cats and dog that actually coming from the dataset that we are using. So you don't need to download the images because the code will show import this dataset to your Jupyter Notebook file. So here, by clicking the new button, new Python, you can start one Jupyter Notebook file. Then here you can rename or save this file to a particular location. And if you want to start the Jupyter Notebook to a particular location, then just open that location in command prompt and write Jupyter Notebook. You will see that the Jupyter Notebook will open this file in this particular location. So let's move to our next slide for understanding the relevant concept first, because without understanding the relevant concept of how to do the coding, it is not easy to start coding. So here you can see, if you want to open your Jupyter Notebook in E drive, then just enter into E drive and type Jupyter Notebook and you can start the coding. Okay, please check the Jupyter Notebook spelling must be correct for that. Here, if you make some sort of mistake in typing that, you will see an error, and when you are typing it correctly, it will open the code here. So we have opened this particular folder where the dataset is located, but we will not use these images from the folder. Instead, we'll run this code on Google Colab, because if your computer's processing capacity is slow, it will take a lot of time for training the model using the training dataset. So if you use the Google Colab, it will work fast, because Google Colab process the code very fast compared to local Jupyter Notebook file. So I'm showing you the process how you can create a Jupyter Notebook file on your folder, on your local PC. And let's move to our next slide for understanding the concepts first. So dear friend, we understood different features of Jupyter Notebook. Let's move to our next slide. What is activation function? It's a very important topic. So activation function is basically a feature of your convolutional neural network. So an activation function is known as a transfer function. It is critical component in the artificial neural network and deep learning model. It introduces non-linearity in the network and allows to learn complex patterns and make decision based on the input data. Activation functions played a crucial role in determining whether a neural network be activated or not based on the weighted sum of the input. In this context of neural network, the activation function is applied to input such as neuron and the layer, and output of activation functions become the input of the next layer. So one particular layer is taking the data and it is giving some output, and that output become the input for the next layer, and this is how it is propagating in the forward direction. So by introducing non-linearity, the model can learn complex and non-linear relationship in the data and make it capable for handling more interactive pattern and achieve higher level of performance. So dear friend, you can see different type of activation functions are available. We'll use particularly the ReLU function. ReLU function is important because these functions return the input as it is positive and 0, otherwise it is ignoring the value. The function is fx is equal to max of 0 comma x. So ReLU become the most commonly used active function in the deep learning during due to its simplicity and its ability to mitigate the vanishing gradient problem. Okay, so what is vanishing gradient problem we have discussed in the previous video number 1. There are other activation function like the exponential linear unit, and we will not use the others. We will use only rectified linear unit. You can search what is the sigmoid function. So sigmoid function is basically maps the input to a range between 0 to 1, and its function is written as fx is equal to 1 by 1 minus exponential of minus x. And this sigmoid function has wide use in the past, but its vanishing gradient problem hinders its application in the deeper network, so that's why it is not so popular. Let's move to some questions and answers. We'll try to understand the problem first using some question and answer. What type of dataset we are using here? We are using CIFR 10 dataset, and CIFR 10 dataset contain around 65,000 images, so small images of various objects, and you can use this for your analysis. So normalizing the pixel value to a range of 0 to 1, and it is essential to our first question is, what is the purpose of normalizing the pixel value of the images from this dataset? So when you do normalizing, the normalizing is of the pixel value, ensure that the features have similar scales, and it helps faster convergence into faster conversion during training, and prevent issues such as exploding gradient. By dividing each pixel value by 255, we transfer the image data to a continuous range, and which is suitable for training neural network efficiently. Then our next question is, what is flattened layer used in the first neural network? The flattened layer is used to convert dimensional input image 32 by 32 into 3. So it is a one-dimensional vector before processing the fully connected layers, and the flattened process is necessary because the fully connected layers required 1D input. The flattened layer preserves the relationship with each channel, and while creating the flat vector suitable for further processing. So let's start the coding and see how it is occurring. So first of all, what you need? First of all, you need to write some code that is going to add the TensorFlow in your particular TensorFlow in your particular Jupyter notebook file. So let's see. Dear friend, if you are using your local Jupyter notebook, then install the TensorFlow using the command pip install TensorFlow. So when you write this command using the command prompt, it will take some time for installing TensorFlow locally. It is around 275 megabyte file, so it will take some time for installation process. During this time, we need to wait for this. So I'm taking a pause here, and here you can see the TensorFlow is installed. Maybe it will show some sort of little error if there is any permission related things there. So once you have installed TensorFlow, then you can write this code from tensorflow.keras, and then you are going to import these relevant packages. So this code start by importing the necessary libraries that include TensorFlow and Keras API, and we'll also need to add some NumPy for numerical operation, and for visualization we'll use Matplotlib. These are some important packages. So you can see we are writing in TensorFlow Keras model import sequential, and TensorFlow Keras model import the conview D, and then other. So here we want to do this coding on the Google Colab for fast processing. So dear friend, we have changed the last line. So here we move this particular code to a Google Colab file. So we are using this code, this import section, and then importing the dataset. If this code is not visible, I'm showing you another way. So dear friend, here you can see the code more visible. We are importing TensorFlow, then Keras, then Matplotlib and NumPy. You can call NumPy earlier also. Then when you write this particular code, it will download the data from this URL and it will add to your Google Colab file. It will take some time, like 7 seconds for running this code, and then you can also see the shape of this data here. So basically what is going on here, let us try to understand it theoretically. So first the code started with importing the necessary libraries, including TensorFlow, Keras API and NumPy, and also Matplotlib is also added to this, and then we are calling the CIFR dataset, and it is loaded and it is dividing into training dataset, so training dataset XY and the corresponding level. So we got 10 classes of images here. The shape of the training dataset are printed here. So you can see the shape of the training dataset is 50,000 images are there, and we are using 10,000 data as test data. So we are training the model using 50,000 images of 32 cross 32 size, and 3 is for 3 RBG layers, and you can see the shape of the training dataset is 50,000 here. The shape of the training and testing sets are printed, and we can check the number here. So in the next line, in this particular, so you can see the number here. And the next line, when we move now the process of data processing. So code normalize the pixel value of the images from the range of 0 to 225. Generally the colors are denoted by a number between 0 to 255, and when we divide these numbers using 250, it reduced to a number which is between 0 to 1, and as a result our data range is between 0 to 1. This step is essential for efficient training of neural network. So here you can see 10 classes are there, and here is a plot sample using index, and the level in the y training and the y test are initially in the 2D shape, and they are reshaped to 1D arrays using ytrain.reshape. So this this dot reshape -1, this particular line is used for converting this particular array into a one-dimensional array. So here you can see this array is a two-dimensional array, and just the 5 datas of training dataset is a two-dimensional array is represented here, and using this code it is converted into a one-dimensional array. So this step is necessary for the categorical cross entropy loss function, and then in the next phase we see some visualization of the data using the plot sample function. So the function plot sample is identifying the visual of a sample image and from the dataset along with the corresponding class level. So here this function takes the dataset and its label and the index of the sample, and you can see the visualization here. So here you can see the label and the image. So it is a frog image, since it is only 220 to 32 pixel cross 36 pixel, and we are viewing it in a large scale, so the frog is not clear here. When we reduce the size, the frog is visible here. So okay, and here another number, when we change this particular number we can see different images. Now in the next step it is time to build your first neural network, which neural network is going to trained with some data, and it will capable to detect the category of image from the test data. So here we are dividing the training data training dataset by 255 and also test dataset by 255, so that these RVG values are reduced to a range between 0 to 1. Here in this particular code, you can see the first neural network is built using the Keras sequential API. So it is coming from the Keras package sequential API, and it start with the flattened layers that convert the 32 cross 32 cross 3 input image into a flat vectors. So here it follows with two dense layers with 3000 and 1000 unit respectively, and the activation function use the rectified linear unit, which introduce non-linearity in this network. So dear friend, the model is so here it start with a flattened layer and then convert it into a flat vector, and then it follows with the two dense layers with 3000 and 1000 respectively, and the final dense layer has 10 units. Okay, and use these softmax activation. So here you can see it is using an activation function softmax activation function to produce probability of each class. In each dense layer, you can see one activation function is used. The last layer is using the softmax. So here the model compiles with the stochastic gradient descent, which is called SGD optimizer, and the categorical cross entropy loss function, and the accuracy is evaluated using a matrix. So when you run this particular code section, it will run 5 epochs and it will try to gain maximum accuracy. So here this model is trained on the training set X train and Y train for 5 epochs. It will take some time. For here you can see the accuracy level, the last accuracy level is showing 49% after running these 5 epochs. Okay, in the next step we will see that in the next step you can see that the accuracy of the training model is evaluated using X text and Y test using classification report from Scikit-learn. So here the Scikit-learn matrix, Scikit-learn is used here for the accuracy of the training model. So here you can see the classification report here, some data from 1 to 9. The accuracy is 44% and weightage average is given. So now we need to build a convolutional neural network to train our image. So here in this particular section, try to understand this code here. The second neural network, CNN, so we are developing another neural network, is construct of image classification. It started with the conv2d. Conv2d is a layer, or you can say is a filter with 32 filters or kernels of 3 cross 3 and followed by the ReLU activation function. So here you can see the kernel size is 3 cross 3, activation function is ReLU, and the input shape is 32 cross 32, 3 layers of colors. And we are also using another max pooling 2D layers of size 2 cross 2 and adding a downsample for the feature image. So here we can see the process is repeated with another conv2d layers and ReLU functions and another max pooling 2D, and then we have used a flatten function of 1D vector. So the feature map are then flattened to a 1D vector using flattened layer, and here we use the ReLU function and the softmax. So the ReLU function and the softmax is helping the classification. The two dense layer with 64 and 10 units respectively are added to the ReLU and softmax activation classification, and this model is compiled with Adam optimizer, and then this model is optimized with Adam optimizers and the categorical cross entropy loss and the accuracy of the matrix is improved here. Here we see this particular function is, this particular neural network is trained with a normalized training, and for 10 epochs, so 10 epochs will maximize the accuracy. So later you can see the accuracy level is 79% here, and then here you can see that the accuracy of this neural network model is evaluated using the test set X test and Y test using the CNN evaluation, and the accuracy is around 70%. Okay, now it is time to do some prediction of the test data. So we are the model predicting Y prep and obtaining on the test set and the class with the highest probability of each sample is executed as a predictive class. So we are predicting for only 5 datas, and you can see the results here, and the classes for in the next step. So you can see the output. The code printed the predicted class of the first 5 sample. So there are actually 3 means, 0 means aeroplane, 1 means automobile, 2 bird, 3 means cat, 4 mean deer. So here the first 5 models are like 3 means this particular code. So here we are supplying say one sample data, and you can see the image, and it is accurately plotting, it is accurately detecting the image. It is a frog image. So lastly, it prints the class name of the predicted class of the fifth sample in the test data, and again we also print the 7th sample and 13th sample. So a basic neural network and a convolutional neural network identified the image class, and now from this code you can see the steps. Here, and from this code you will get some question and answer. Like, let me show you the question and answer here. Once again, I'm showing you the code here. This part is for importing the necessary package, this part is for importing the data, and these are just for checking the shape and checking the data. Here you are defining the types or classes, and then you are using some functions. Here we have discussed about this. Now let me show you some question here. Okay, so what was the purpose of normalizing the pixel value of the image in the CFR dataset? Why the flattened layer is used in the first neural network? So the flattened layer is used to convert the 3-dimensional inputs to 1-dimensional vector. That was the reason. Next question is, what activation function is used in the dense layer of the first neural network? So we use ReLU function, rectified linear unit activation function is used in the dense layer of ANN, and ReLU is popular activation function that introduce non-linearity and help in overcoming the visual gradient problem, and it replaces all the negative value with 0 and keeping the positive value unchanged. And how the loss function defined for training the first neural network? The loss functions are used for training the ANN for the purpose of categorical cross entropy. The loss function is suitable for multi-layer classification problem where each input sample belongs exactly to one class, and this variant is used since the class label is provided as integrated integers rather than one hot encoded vector. Let's move to our next slide. Why the neural network architecture prefer for image classification tasks? So why it is prefer? Because neural network prefer for image classification due to some ability of automatically learning hierarchical feature from the image. The CNN are used for convolutional layers and that detect local pattern and feature of an image, followed by pooling layers and downsample and reduce the dimensions. What is the purpose of using max pooling 2D layers in the second neural network? So in the second neural network, we use max pooling 2D layers for this operation reduce the spatial dimension of the feature map while retaining important information. Max pooling help in making the model more robust to translation and reduce the number of parameters, which aids the preventing overfitting. Our next question is why the Adam optimizer use for training the second neural network. So Adam optimizer is a popular adaptive training, and it is used for training a neural network, convolutional neural network, because it combines the benefit of both adaptive learning rate and monument based optimization technique. Adam adapts the learning rate based on the moving advantage of past sequence gradient and make it well suited for training deep neural network and achieve faster convergence. Our next question is how is the accuracy of the second neural network evaluated in the test dataset? So the accuracy of second CNN of the test dataset is evaluated using the cnn.evaluate x_test y_test function, and this function import the loss and the accuracy metrics on the test data and return the test accuracy as a result. Let's move to our next slide. And what is the purpose of classification report for Scikit-learn? What is the purpose of classification reporting from Scikit-learn? The classification report is a utility function from Scikit-learn used to generate comprehensive classification performance report, and this provide precisions, recall, F1 scores, and support each classes in the classification problem. And this report help in understanding the model performance on the individual class and overall accuracy. So you can see the classification report of the classification function here, and why this classification report is used from the Scikit-learn. We understood that it generate a comprehensive classification performance report. You can understand the model performance from that report. Our next question is how does the second neural network outperform the first neural network for image classification? That is a very important question, and we use this particular data set. So the CNN architecture in CNN outperform the base network of image classification due to the following reason. CNN can automatically learn and detect hierarchical feature from images using convolutional and pooling layers. CNN are specially designed for image related tasks, leverage the spatial relationship in the data. Pooling layers in CNN reduce spatial dimension and help in making the model more robust. CNN have fewer parameters compared to fully connected layers, which help prevent overfitting. The ReLU activation function in the CNN introduce non-linearity, enabling the network to learn complex patterns more efficiently. Dear friend, let's see some. Here we are just training our dataset using 10 epochs. You can see it will take some time. In the meantime, let's see some question and answer relevant to this topic. So what is epoch? It is a very important question. What is epoch? Let's see. So in the context of training a machine learning model, an epoch referred to single pass of the entire training data set and through the neural network. During each epoch, the model iterate over the entire dataset, update the parameters like weight and bias, and you can see the epochs are running right now. So entire dataset is running through your network. So during each epoch, model iterate over the entire dataset, update the parameters of weight and bias, and it calculate the forward and backward propagations step. Like forward propagation means during the forward propagation, the model takes the input data and pass it through the layers of the neural network and calculate the output or prediction for each sample. There is loss calculation. So loss calculations are like loss calculations during the forward propagation. The model compared the prediction to the actual target level from the training data set, and the difference between the predictions and the true levels is measured during the loss function, and which quantify the error of the model's prediction. There is backward propagation. Backward propagation means once the loss is computed, the model performs backward propagation. It calculates the gradient of the loss with respect to model's parameters using the chain rule of calculus, and the gradient to represent the direct and magnitudes of the changes required to maximize the loss. Then you have the parameters update. With the gradient compute during the backward propagation, the model update the parameters during the optimization algorithms such as gradient descent and one of its variant, and the goal is to adjust the weight and the bias in a way that reduce the loss and thereby improve the model's performance. There is iterative through the entire dataset. The above steps are repeated for each sample in the training dataset, and after doing this you can see that your dataset, your particular model is performing better. So when one dataset is completely trained through the model, then again we train the model using the same dataset. That's why multiple epochs are there. The number of epochs is a hyperparameter that the data scientist or the developer set before training the model, and it is important to find the balance in the particular. So it is when too few epochs are used, and then you can face some underfitting situation, and when too many epochs are used you will see some overfitting situation, and so you have to use at least 10 or 5 epochs for training your dataset. So dear friend, I hope here you can see the steps we use in this particular project. Here is a summary. First we load the data and then do the exploration. So you can see for loading we have used this sample code. Here we are importing the functions, and then we check the dimension or shape of the function, shape of the data. So these are done in this area. Then we define the classes here as an array, and then we train this is data preparation stage. Here we divided all the pixel, we change the pixel value, just its range is changed from 0 to 255 to 0 to 1 by dividing 255. Okay, and then we use some plot sample function. So where we use some plot sample function here, and plot sample function. After doing the plot sample function, you can see the results here. After doing this, using this plot sample function, you can display the image and the label. And after that plot sample function, we build our first neural network ANN and use the activation function ReLU. So here this is the first neural network is using. We use 2 dense layer, actually 3 dense layer and 1 flattened layer of 3 cross 3, and 2 activation function and 1 activation function as softmax. So you can see this here. As a result, we run 5 epochs after that for training our model, first CNN, first neural network model, and then we use another stochastic gradient function as an optimizer, and the code is here for categorization. We have discussed this, why the stochastic function is used, and then the model is then trained with the training set. Where this is done, you can see here, you can see the accuracy around 59%. In the next tab, we create a category accuracy training model is evaluated using the classification report. So how the classification report is used, here we have imported the particular function here, classification report, and it is producing this classification report here. Then we are building our second convolutional neural network using several layers, 1 flattened layer, 1 dense layer, 2 dense layer, and we use the con body and max pooling 2D 2 times here. So we start with con body layers with 32 filter kernel of size 3x3 and the reloop attribution function, and again we run 10 epoch using this second neural network, and now our model is more trained for testing the data. So you can see we train 10 epochs. All the images are passing through this network and the accuracy level is 79% is achieved. And now we are testing our test data contain around 313 images, and here it is showing the first 5 images category here. So the step is, after that the model predict y prep and obtain the test data, and lastly it print the class name of the predicted class of the 7 sample in the data. So you can check 7 sample of the data. So this is how we completed the classification, image classification using neural network. I hope this video is helpful for you, and the sample code is here in Google Colab. We have used only these steps, and I will share this as a link on the description below. Thank you so much for listening. See you guys in the next episode. Hello friends, hope you are doing well. Welcome to another episode. Today we are going to discuss about data preparation. Data preparation is the process of cleaning, standardizing, and enriching raw data to make it ready for use in analytics and data science. So what is the definition of data preparation? We have learned from these slides. Once again, data preparation is the process of cleaning, standardizing, enriching raw data to make it ready for use in analytics. Now, it is a very important part of machine learning. When we get some data, generally it is in CSV format, right? That means comma separated value. So you must know how to load data before you can use it for machine learning model. So when we start collecting some data have some sort of problem, and you have to clean those data before loading to a machine learning model. It is a good idea to stick with small in-memory dataset using standard file format like comma separated value. So in this video we are going to discover how to load data in Python from scratch. So we will first create a CSV file, or we have a CSV file. I'm showing you. Suppose we have a CSV file here, simple CSV file. These are the list of tourist places in Nepal, and these are the number of tourists that are visited in 2016 and 2017, and here is the number of changes. Very simple CSV file. So how to convert the strings from a file to floating point number? We'll learn how to convert class values from a file to integer, all those things. So first of all, what is comma separated value or CSV? That is a very important kind of file format. I think you already familiar with comma separated values. It is actually the simplest form of data. Each rows are divided into column like this example, and if I open this same file in Notepad, then you will see this value as comma separated value. So I'm opening this using Notepad. Here you can see the values are in here in comma separated values. So in this tutorial I'm just going to use this simple CSV file as a data file, and there are many other popular datasets are available. One of the major popular dataset is Irish flowers species database. Here friends, we have a very common data set which is called Irish flower species database or dataset. So in this video we will use this Irish flower species dataset. You can see in Excel file right now it has the column like serial number, then spal, sepal length, sepal width, palette length, palette width, and the species name. So this dataset involves the prediction of Irish flower species based on this information. The baseline performance on this problem is approximately 26%. So you can find these database down in Google, in GitHub, and you can see there are 150 records are available, and in the species section you see there are three major types of species: Setosa, versicolor, and virginica. Three species. Okay, so let's start. First we will load the file on our Jupyter notebook, then we will do a little bit of analytics of tasks, and then you will understand how to analyze this kind of data. So before that, I want to give you a little bit brief introduction of machine learning as an introduction, and then we'll go to CSV file load section. So what is machine learning? Learning is any process by which a system improves performance from experience. As a human being, we can do a task based on our previous experience, and for that we have to do the same tasks again and again, and then we understand how to do this. Machine can also learn when you send data and output to a computer program, then computer program can write the program. So that is the way how machine learning work. Traditionally, when we start learning computer science, we understood that if you have some data and you have a program, then based on that data and program, computer can give you some output. Here in machine learning, you send some output and data, then computer understand these data and gain some experience from that data, and then it can write the program. So we call this data is training data. And what types of tasks that computer perform is kind of algorithm. So when do we use machine learning? Machine learning, human expertise does not exist on sometimes when you cannot explain something based on some data, then you take the help of machine learning so that machine can give you some analytics and insight. We see the use of machine learning in various sectors like face recognition, then talking to a generative AI like ChatGPT, Siri, or Alexa, then Google Bard. We see the use of machine learning in case of healthcare in terms of diagnostic any disease. We see weather forecasting. We see it in content platform like Netflix during the recommendation, and especially the marketing industry analyze a lot of data for their next marketing campaign. So there are three types of machine learning available. One is supervised learning, unsupervised learning, reinforced learning. We have detailed video on each topic. Supervised learning, when you give some training data which is labeled data, and based on that training data your model can predict from on test data. So you train your model again and again with some labeled data, and then it can predict your test data that is supervised learning or inductive learning. Unsupervised learning, when you are not giving any sort of label data and computer is actually giving you some prediction. Reinforcement learning, reward from the sequence of action. So this is a special type of machine learning. Especially supervised and non-supervised learning are more popular. So in case of a supervised learning, we see some other examples like regressions. We learn from a function. The machine learning model create some sort of functions like fx is equal to y, that is y is a function of x is independent, and sorry, y is dependent and x is independent. So when we plot some graph and we see there is a best fit line which is possible from this plot, we create a kind of equation for this line, and that equation is nothing but y is equal to fx plus e is the amount of error, and fx y is equal to mx, m is the slope of the line. So a simple formula is possible, and sometimes we see the data in some cluster format, and like blue buttons are placed and place in a particular area and green buttons are placed in another particular area. So in that case we see a kind of classification from this plot, and this is how your model is trained for doing the classification. So here is the step-by-step process how you can do analysis using machine learning. First, you have to collect some data from right resource. Collecting data from right resource is very important part. If you are not collecting relevant data, you cannot do right prediction. Then data preparation is the part where you clean your data for the model, then you choose a correct model, then train your model with the data. There are various type of models available, or you can create your own model based on your assumption, or sometimes you get ready to use models. Models are based on some algorithms, so you train your model using your training data, then you evaluate the model how accurately it is doing the classification or prediction, then you make the prediction based on test data. So these are the simple step-by-step process of building your own model, and for that various type of Python libraries are available in machine learning. The libraries are NumPy, Pandas, Scikit-learn, Matplotlib, then TensorFlow, etc. So these are actually packages of Python, so this is not so difficult. So our today's dataset is Irish flower dataset. So we, dear friend, we have shared this example. Let me show you the data. Here is the data. It has this column, and this is the serial number, this is the sepal length, sepal width, palette length, palette width, and these are the species. Now before that, before doing the analysis, we have learned a little bit about machine learning. The Irish flower data set was introduced by Ronald Fisher in 1936, so very old data set. This is sometimes called the Anderson Irish dataset because Anderson collected this data to quantify the morphologic variations of Irish flowers and 3 related species. The use of this dataset is cluster analysis, and which is very common in machine learning, and we'll learn how to separate these species based on this data. So first, here in this diagram you can see 3 different species of this flower, and the they are identified based on their sepal and palette size. You can see in this picture one of the cluster contain iris setosa, while the other cluster contains both iris virginica and iris versicolor, and is not separated without the species information. And these it is multi variety, more than 2 different variations dataset are available. So let's do some sort of activities on some sort of analysis on Jupyter notebook, and we can start from there. So dear friend, here in this CSV file we see that there are 5 major columns are there. So here you can see the 4 information: sepal length in centimeter, sepal width in centimeter, palette length in centimeter, palette width in centimeter. These 4 informations are numeric information. Okay, so we are going to do some descriptive statistic analysis, and let's see. So dear friend, we have opened the Jupyter notebook and we have created one new file and renaming this file as iris dataset. So let's start our analysis. So first of all, in the first line we are going to import the pandas. So write import pandas as pd, simple. Then import numpy as np, then import Seaborn as SNS, then import Matplotlib for graphics, for the charts. This is a library for chart, is a Python library. Using this you can create nice plots, nice charts. Matplot as plt. If you are doing any typo mistake during doing this, then during running the program you will get this error message. So from warnings import filter warning. Now file filter warning, filter warning action is equal to ignore. Let's run these lines and see whether there is any errors or not. Filter warnings, run, we see no error, fine. Now irish is equal to pd, means pandas dot read. We are using pandas for reading the CSV file. Read underscore CSV. This is how we are loading this data, and the file is located on the same location where this IPYNV file is located. That means this notebook file is located. So our file name is irish.csv. Now we are going to print this file, print iris, and let's see what is there. Run. So we see these files. Let us compare this file. We have shown you this file in Excel, and we see that 5.1, 3.5, 1.4. So these are the initial rows, these are the final rows, last 5 rows, and the first 5 rows starting from 0. And these are some additional columns. So this is column number 1, 2, 3, 4, 5, 6, 7 columns. So when a new column is there, you can see this rows again. So in total 12 rows are there and 6 columns are there in this file. Now we want to know more about this database shape, how many rows and columns are there. So formula is print, then write irish is a variable here, dot shape, and run. So in total we have 12 we have 150 rows and 6 columns. Now we can use another command for describing this data. So print irish dot describe, then within bracket. So using this formula, using this command, we can describe the data. Run. So you can see the count in total 150, mean is 75, and the mean of this spal length is 5.84, spal width is 3.5057, standard deviation is this, minimum is this value, maximum value is this, and 75% values are having this average, 50% values are this average, and 75% values are having this average. So we are getting some information from this valuable information from this data set. Now we want to do further analysis on top of this data, and for that we are going to use another formula. Here we want to check the null values. So our goal is checking for null values. Print formula is print irish dot is na, is there any null value available, dot sum, and we also want to print dot print irs dot describe. Okay, run. So we see from this command that there is no such null value available in this column. All columns have the data, sufficient data. There is no null value. So we want to see the header of this CSV file. The formula is iris dot head of this CSV file, and then run. So it is showing that these are the head. Okay, now we want to see all the data. So in that case we can use the same command, and here we are going to pass the parameter 150 for viewing all the data. Run. It will not print all data, just initial 5 data and last 5 data, and telling you this file has 150 rows and 6 columns. If you want to display say first 100 rows from this CSV file, then you can pass here just 100 or 110, whatever your requirement. I can try say 50. I want to see only 50 data. So here you can see 50 datas are first 50 datas are printed here. Now in the next line we are declaring one variable n is equal to length 10 of irish within bracket these species species. You have to use the correct spelling of the header for this. Is equal to the species is equal to versicolor. Now versicolor, and then print. We want to print, what do we want to print here? The number of versicolor in the dataset set is equal to n. So comma n. Okay, so using this line we can count how many versicolor species are available in this dataset. Run it. The number of versicolor in this dataset is 50. So we are using the same formula for calculating the other species. So at this time I'm using n1, and the species name is virginica, and the total number is again 50. We are using the same code for calculating the third species. So third species name is Seaborn. Run. It is again 50. Now we are going to draw a pie chart now for viewing the percentage of different species in this data. So we are going to use this command. Figure is equal to plt, that means we are calling the matplotlib dot figure. This is the function. Next line, ax is equal to fig dot add underscore axis, and within function 0 comma 0 comma 1 comma 1, then ax dot axis equal then L is equal to 3 spaces. We are going to copy this, comma spaces 2 comma this spaces 3, then else is equal to, we got the count 50 comma 50 comma 50. Now we want to plot a pie chart here. So ax dot pie s comma levels is equal to L comma auto pct is equal to colon percentage 1.2 f percentage plt show plt dot show. Okay, after writing this code, when we run this, we see some error. We have to fix this error. I'm just doing a spelling mistake here. I fixed this, run again, it is having some error. Okay, simple error, typo mistake. Now we can see this graph here, 33.33%, 33.33%, 33.33%. So how to draw a pie chart like this, you have learned, like using this formula. This is the format how you want to display these labels here. Now we want to create a box plot using the same thing. So I'm going to copy paste this formula here. So you can see this formula for copy for the box plot. Run it, you can see the box plot like this. So in the first item, we see that somewhere the length is between 5.5 and 6, and next we see there are some outliers, 3 outliers, and the value is somewhere between 2.5 and 3. Now we want to see the histogram of this data. So iris.hist plot show. So it is showing the histogram. This is the histogram of the sepal length. Sepal, I need to minimize a little so that you can see this. Now we want to create some more graph using our plot. So here we are using some more graph, and you can see these graphs here. We want to create some box plot for all the columns for better analysis, and this is the box plot for all the columns. Now we are going to create some shapes based on the species related data, and the formula is like this. So you can see the data like this. Here we can see the value of palette length. Here for a particular species, the length is in between 1 and 2. Here for this particular species, the length is between 3 and 5. Here for this particular species, the length is between here. So you can distinguish these palette length, palette width, palette sepal length, sepal width. So 3 valuable graphs are there. Now we are going to peer plot using SNS package. Why SNS was used? SNS is Seaborn. So Seaborn SNS. Okay, we have to run this so you can see the data. Now we are going to create a heat map for better understanding, and heat map is very valuable graph for classification, and we are going to run it here. So here is the heat map. So you can see that the sepal width is here more dark and less dark in these areas. So dear friend, you can see a visualization of this data. So it is a heat map. A heat map is a data visualization technique which is used to analyze the data set as color in 2 dimension. So here you can see the color density is increased at the bottom and decrease at the top. So increase means the value is high, and decrease means value is light. So here a heat map can be very useful for analyzing the data. And here in this particular iris data set, we see that it contains 50 samples of 3 different species, and this species is Setosa, virginica, and versicolor. 4 features were measured in these samples, and the features are the sepal width, sepal length, sepal width, palette width, and palette length. And based on that, we have created this heat map. So this heat map is representing a matrix of colors. So now we are going to display the value of sepal length 50, all the values of sepal length here, and here we want to display all. Now if we create a dot plot like this, you can see a shape like this, and we want to find some correlation from this data. And for finding the correlation, we can use this command. Here you can see. Now we'll use some logistic regression using Scikit-learn in this particular data, and for that we are first using the Scikit-learn logistic regression model. Then we are going to split the data for training. So we have 150 data, so we have split the data for training, and then we also importing the k neighborhood classifier from Scikit-learn. Then we are also importing the SVM. It is another algorithm, support vector algorithm, and we are going to import another matrix here. Now we are going to import another decision tree. So all these algorithms are imported here from Scikit-learn. So run them. There is no result right now. Now we want to train our model using some training data. So we are going to take 25% data randomly for the training. So from these lines of code, we are printing the training data and test data. Run. So we are using 112 record for training and 38 records for testing. Now let's do some training, and for that we are using this code. You can see the columns are there in this training x-axis. Y-axis is the species. So we want to get the result, what kind of species is there based on these 4 feature. So our x-axis are the features and y-axis is the result. So we want to find out the species here. So run this. Nothing is showing. We just want to show the header of our training data. So we have sepal length, width, palette length, width, etc. So randomly these datas are taken. These are the random values. Now when we want to see the head of this test data, that is test y, our test data has only 36 items. So run it. Our test data randomly taken 100, 360, 17, 73, etc. So species name and object. Now we want to see the results of the test y again, and we see another data. Now we want to see the accuracy percentage of this model. We want to calculate the accuracy percentage of the model. Run it. Accuracy percentage is around 1, and we want to check the other metrics. Run it. We get the confusion matrix here, and for confusion matrix here, and now we want to use the support vector and want to check the accuracy. Run. Accuracy is 90.94. we want to use the k-means, k-neighborhood, and want to see the accuracy. Run. Accuracy is 1. We are going to use Gaussian naive Bayes and going to check the accuracy is 1. We are going to use the models, these models, logistic regression, support vector machine, and naive Bayes, k-neighborhood, decision tree, and different values. These are scored from there. So we see that logistic regression is 1.0, logistic regression 1.0. then support vector machine is this up to 3 decimal. We are taking the value up to 3 decimal. And then naive Bayes, Gaussian naive Bayes is again 1. Then k-means is again 1. Decision tree, did we use decision tree? Oh, I see, we have not used the decision tree yet. We are keeping this record for later use. So accuracy is 3.7. We are going 471, then 1.94, 1, 94. Okay, run. So these are our model score. So we have used the machine learning in Irish data. I hope you have learned something about machine learning from this tutorial. Thank you very much for watching. Hello friends, hope you are doing well. Welcome to another episode, and today we are going to discuss about deep learning. If you are learning business analytics and you have started understanding what is artificial intelligence, what is machine learning, then understanding about deep learning is very important for you, because nowadays when you go for an interview for a post like business analyst or a junior level data scientist, you will get a question about deep learning. What is deep learning? How you can utilize deep learning in your business analytics role or something like that. So this kind of questions are obvious. So let's move to our slides, and we'll also take the help of ChatGPT for explaining some points time to time. And what will be the benefit of watching this video? After watching this video, we will get familiar with different vocabularies of deep learning, and you'll understand what are the things you need to focus for learning deep learning as a beginner. So without further ado, let's move to our slide and start the deep learning related class. I'm assuming that you have a little bit idea of what is machine learning, different type of machine learning, what is supervised machine learning, unsupervised machine learning, reinforced machine learning. So we'll use the term supervised learning, unsupervised learning time to time here in this conversation. So if you are a complete beginner, you can check out my business intelligence related 3-hour masterclass which is available in this channel as business intelligence and business analytics bootcamp and 2023, and you will get some basic understanding. So without further discussion, let's start our today's class on deep learning. What is deep learning? So dear friend, deep learning is a subset of machine learning. that focus on using artificial neural networks to model and solve complex problems. And it is inspired by the structure and function of human brain, where interconnected neurons work together to process information. And deep learning algorithm attempts to replicate the process by multiple layers of artificial neurons to learn and represent data in a hierarchical manner. So what is artificial neuron? It is similar to our biological neuron. In biological neuron, you can understand that if you have read this in your biology class in school days, like it is a small cell that contains some receptor part, and it transfers the signal to the next level. So here in deep learning, the same concepts are used, but you will need to understand them using the language that data analysts use for explaining them. So let's move to our next slide, and next slide we'll understand what types of models are utilized in deep learning. Of course, it is a subset of machine learning, and in machine learning you know that different type of models are used, like something like support vector is an algorithm. Using that algorithm you can create a model. There are random forest algorithm. Using that algorithm you can create a model. So here in the deep learning you are also using different type of models, and we can divide this model into three major types. So what are these types of model? Let's move to the next slide and see. There are major three types of models. One is directive generative model, two is undirective generative model, and three is mixed generative model. Let us try to understand these three models using simple explanation. So what is directive generative model? The word directive means you are actually giving some sort of direction. So directive generative model is also known as a generative model with explicit latent variables, and these models generate some data based on some directions. Actually you are training the model using some training data, and it is creating the similar kind of data based on that training data. So the latent variables which are observed or hidden and explicitly model and play a very crucial role in the generation of data. So here we'll take the help of ChatGPT for understanding a directed generative model using some simple explanation. And if we understand what is directive generative model, we can also understand what is undirective generative model and what is mix. So dear friend, directive generative models are also known as directive generative neural network, or in simple, directed generative models are a class of powerful machine learning models used in the field of deep learning, and this model belongs to broader category of generative model. So generative models, as the name suggests, are designed to generate new data that resemble some existing data distribution. Think of like a machine learning artist that can create a new example of data after learning from a set of examples. In the case of directive generative model, the directed word is used because they learn the relationship between the input data and output data in a supervised manner. So supervised learning means that the model learns from the label example where each input data has a corresponding desired output. The images that have a data set of cat and dogs images where each images is labeled as either cat or a dog, the directive generative model would learn to take a image as an input and generate a output as a prediction like cat or dog. One popular type of directive generative model is the conditional generative model. It works by learning the generative output like image or text based on both input data and some additional conditions. Going back to our example, a conditional generative model might learn to generate images of cats and dogs based not only the input that you given as image, and also some other information like the color of the cat and dog and the pose of their standing, etc., and from relevant feature. So based on a set of images of cats and dog, this kind of model can generate a new cat or a dog image. These models are built using deep neural networks, which are large networks of interconnected artificial neurons inspired by the structure of human brain, and deep learning allows the model to learn complex pattern of representations of data, enable it to create more realistic and meaningful output. The directive generative models have numerous practical applications such as image synthesis, style transfer, data augmentations, and even in some natural language processing tasks as well. So in summary, what is directive generative model? Are a class of powerful machine learning models that can generate new data based on the supervised learning, where they learn a map input data to correspond outputs. They can be used for deep neural network. They can be used as a deep neural network to learn complex pattern from data, making them capable of creating meaningful and realistic data representations. Now, I am sure that you are clear about what is directed generative models. Now, from that conception, we can also understand what is undirected generative model and what is mixed generative model. So, undirected generative models learn by assigning energy score to data configuration and finding low energy configuration to generate new data. Now you will ask me, what is energy score and what is low energy configuration, etc. Let us try to understand it in details. So undirected generative models, also known as the energy based model, this is a class of generative model that do not explicitly model the direct relationship between the input and output data like in a directive generative model. Instead, they learn by assigning an energy or score to each possible data configuration. The idea is that low energy configuration corresponded to more probable data points and high energy configurations are less likely. To generate new data using an undirected generative model, the model typically employs as optimization process to find the configuration with the lowest energy, which represent the most likely data points. In other words, the model generates data by finding the data configurations that fit well with the learned energy function. The popular type of undirected generative model is the restricted Boltzmann machine, or RBM. RBMs are used in unsupervised learning tasks such as collaborative filters, dimensionality reduction, and feature learning. On the other side, there is another type of model which is called mixed generative model. Mixed generative model combine both directive and undirected generative model to benefit from the strengths of each approach. These models are consist of both type of models. So certain part of the generative process is modeled using directive generative models, and some other part of the model is using undirective generative models. By leveraging both type of model, mixed generative models aim to capture complex data distribution more effectively. For instance, directive generative models are good for capturing the supervised relationship between the input and output data, while undirective generative models can better capture the high dimensional correlation and dependency with the data. One well-known example of mixed generative model is Deep Boltzmann machine, or DMB. DBM. DBM combines RBMs with deep neural networks to create a powerful generative model capable to handle complex data distribution. So these three concepts are very helpful for beginning what is deep learning, and you will get some interview question explain what is directive, undirective and mixed generative models in any interview. I hope you understand it from this conversation. So let's move to understand first what is deep directive network. Dear friend, before understanding what is deep directed network, will need to understand what is actually DNN, that is deep neural network. So a deep neural network is a type of artificial neural network that consists of multiple layers of interconnected artificial neuron. In our brain, neurons are connected to each other. There are millions of neurons are there, and one neuron transferring signal to other neuron. That is how it works in general. So here we are using the same concept of multiple layers in this deep neural network. So it is an artificial neural network allowed to learn from multiple layers. So in this particular model, when a complex data is analyzed, these networks use some multiple layers, interconnected layers. These networks are called deep because they typically have many hidden layers between the input and output layers. So in a deep neural networks, information flows from the input layers through a series of hidden layers, with each layers transferring the data representations layers from the previous layer. That means the output of previous layer is working as input of next layer, and those layers are hidden, and we get the final output. The final layers known as the output layers and provides the network's final prediction or output based on the process information. The depth of the neural network is the set of deep neural networks apart from shallow neural networks. So here deep means there are multiple hidden layers in there. In shallow networks there are few hidden layers. So in deep neural networks we have dozens of hidden layers. Deep neural networks have gained the popularity and revolutionized various fields of artificial intelligence such as computer vision, natural language processing, speech recognition, and many other tasks are possible using those deep hidden layers. The ability to learn hierarchical representations from data allows deep neural networks to capture and interact patterns and solve complex problems that were previously challenging for the traditional machine learning algorithm. That's why this deep neural network is getting more popularity over the traditional machine learning model. The learning process in deep neural network typically involves training on large labeled dataset, adjusting the weight and bias of the of the neurons during the process called backpropagation, and the optimization process allows the network to minimize the differences between its predictions and the true levels, making it a better at making accuracy in the prediction and prediction on some unseen data. So deep neural networks have become a fundamental tools in the modern machine learning and have contributed a significant advancement in various real world applications, and it is making a core component of many state of art artificial intelligence system. So dear friend, we understand what is deep neural network. You will also need a little bit understanding about what is deep belief network. What is deep belief network? So deep belief network is a type of generative model that combine both directive and undirective connections in these architectures, and it is designed to capture the advantages of both deep directive network and undirected models. And these deep belief networks have been shown to a very effective learning hierarchical representation of complex data, especially in context of unsupervised pre-trained of subsequent supervised learning tasks. So let us try to understand this using some simple explanation. So deep belief network is a very important concept similar to deep neural network. Deep belief network is a type of neuron network, deep neural network, that belongs to the family of generative model. It consists of multiple layer of stochastic latent variables or hidden units, and it is primarily used in unsupervised learning tasks for feature learning and data representations. The architecture of deep belief network is typically based on a stack of restricted Boltzmann machine, and a RBM is an undirected generative model, which means it learns to model the distribution of the input data without any label output. Each RBM in the deep belief network is a bipartite graph with a one layer of visible unit and one layer of hidden unit. The unit which within each layers are not connected to each other, only between the visible and hidden layers. Now let us try to understand it in a better way, like the pre-training process of deep belief network involves two-step procedures called greedy layer wise unsupervised training, and the pre-training, that is the unsupervised learning. Each RBMs in the deep belief network is trained in a unsupervised manner using a set of unlabeled data. The first RBM is trained on raw input data, learning to model the underlying patterns in the data and capture relevant feature in the hidden layers. The subsequent RBMs are trained on the hidden layer activations of previous RBMs and learning to capture more abstract and high level feature from the representation learned by the previous RBMs. The process is repeated layer by layer until the RBMs are trained. This purpose of pre-training is to initialize the DVN in such a way that it capture meaningful hierarchical representations of data. The initialization helps the network to subsequent supervised learning tasks, especially when the amount of labeled data to limited and when the task is complex and require deeper understanding of data. And then there is fine tuning. Fine tuning is a kind of supervised learning. After the pre-training phase, the deep the deep belief network is often followed by a fine-tuning step using labeled data. During this fine-tuning, the network is adjusted using supervised learning techniques such as backpropagation to minimize the error between the predictions and tuning level of the training data. Fine-tuning allows the network to adapt representations to the specific tasks at hand while while retaining the useful hierarchical feature learning during the pre-training. So by using this unsupervised pre-training phase, the deep belief network can initialize itself with useful feature representation, even in the scenario where labeled data not is not available, or the pre-training step has been shown the benefit here. So nowadays, with the improvement of optimization technique and when dealing with large data set, these concepts are very helpful. So dear friend, you need to focus on these two particular concepts. One is deep neural networks and deep belief network. Try to read more about these two topics for understanding deep learning. Let's move to our interview questions about deep learning. First interview questions. Generally, I'm not going to discuss other things right now. So what is deep learning and why should we use this? And so we understand from that deep learning is a subset of machine learning that focused on training artificial neural network to perform tasks that typically require human-like intelligence. It inspired by the structure of human brain, where neurons are interconnected in a complex network and transmit information through electrical signals. The primary goal of deep learning is to enable computer to learn the large amount of data and make accurate prediction and decision based on that learned knowledge. Unlike traditional machine learning algorithm, which required feature engineering and manual identification of the relevant feature in the data, deep learning algorithm automatically learn hierarchical representation of data, allowing them to extract complex pattern and feature directs from the raw input. Some key aspects of deep learning that are crucial is unprecedented performance, big data and scalability, more than automation and efficiency, wide range of application, cutting edge research and development, competitive advantages, future technology trend, etc. So here deep learning is a fundamental component of broader field of artificial intelligence. As AI continues to shape the future, understanding deep learning is essential for keeping pace with this evolving technology landscape. You are getting competitive advantages. Organization that embraces the deep learning into their system, they can use the they can use the advantages of AI and harness their system with more data driven ideas, and that improve customer experience, that optimize the business process and automate the tasks that save time. You are using cutting edge research and development of deep learning, and that means you are staying up to date with the advancement of AI. And there is a wide range of application of deep learning in industry, all sort of industry, including healthcare, finance, then manufacturing, transport, entertainment, etc. Now it is a very complex mathematics based knowledge area, where you are frequently using some mathematical explanation and concept, because it is very much connected to statistic and mathematical algorithms. But if you want to avoid those mathematical concept, you just try to understand different concept. Like in today's class we have discussed about deep belief network, we discuss about deep neural networks, so DNN, DBN. We'll frequently use the word RB and like restricted Boltzmann machine. So you will get familiar with this after practicing this. What is greedy layer wise unsupervised training, what is top layer training. Try to understand this using simple explanation. So you can use some simple prompt on ChatGPT like explain greedy layer wise unsupervised training using simple word. So it is actually they will explain it using some terminology. For example, what is greedy layer wise unsupervised learning? The first two hidden layers are trained in a greedy supervised manner. Each layer is trained as a restricted Boltzmann machine using contrastive divergence, and this involves passing over the training data multiple layers and update the weight to maximize the likelihood of the data. So basically there are many hidden fields. So one hidden field is taking some input and it is sending the output to the another hidden field, and it is constantly improving the accuracy as you are adding more data to that. The what is fine tuning? So after training some unsupervised layer, the network needs some fine tuning. So for fine tuning you use some label data, and using those label data it adjust is the weightage and improve the classification accuracy. Okay, so dear friend, we here in this particular example you can see that it is a very simple diagram that shows different weights are given to these particular layers, and as a result we are getting the more accurate answer. Dear friends, you also need to understand deep multiple layers perceptions or MLP. So what is MLP? Deep MLP. So it is a type of artificial neural networks that consist of multiple layers of interconnected neurons, and it is a fundamental and widely used architecture in deep learning, and it forms the base of many complex neural network model. So understanding deep multi-layer perception is very important. A deep multi-layer perception is a class of feed-forward neural network, meaning that information flows in one direction from one layer to another layer. And when information is flowing from one layer to another layer, so input of first layer produce some sort of output, and that output is input for the next layer. So from the layer input layer through some hidden layers to the output layers, the final layer is known as the output layer. In between that there are many hidden layers. So each neuron in a new layer is connected to every neuron in the subsequent layers, and each connection is associated with some weight. And the neuron in the hidden layers use activation functions to introduce non-linearity into the model, enabling it to learn and represent complex patterns in the data. In deep MLP, it uses multiple hidden layers. So the terms deep refers the depth of the networks, which determined by the number of hidden layers it contains. So it is like a black box. You are not sure how many hidden layers are there. So deep MLPs typically have more than one hidden layers, and more layers means it is more deeper. The advantage of having multiple layers in the deep MLPs is that allows the network to learn hierarchical representation or representations of data. Each layers can capture different level of abstractions, which with lower layers learns simple features, and higher layers learns more complex and abstract features based on the combination of low level features. So training a deep MLP involves feeding some input data through the network and computing the output, comparing them to the true levels to calculate the error. The goal of training is to adjust the weight in such a way that the error is minimized, which is usually achieved through optimization technique like propagation, stochastic gradient descent. So deep MLP use in a huge range of tasks, including image recognition, natural language processing, speech recognition, and so on. And they have shown a remarkable success in various domains, especially when providing with a large amount of labeled training data. Additional advancement is optimization of algorithm and hardware have made training deeper network more feasible, because nowadays hardware are more stronger than the previous hardwares. So you can see there is a great benefit to this hardware manufacturer company due to the use of deep learning, because companies are using those hardware for analyzing their data. So dear friend, finally we are going to discuss some key feature of deep learning in this particular phase. Number one is neural network. You are now clear about neural network. Deep learning relies on neural networks, which are computational models composed of interconnected layer actually of artificial neurons. So what is neural network? Neural network is a collection of interconnected layers of artificial neurons. What is artificial neuron? You can guess what is artificial neuron. So deep learning relies on neural network. We understood that. And what is neural network? Neural networks are computational models composed of interconnected layers of artificial neurons. Each neuron performs a simple operation on its input and passes the result to the neuron at the next layer. Okay, we learned about different models as well. What is the next feature? The next feature is deep architecture. What do you mean by deep architecture? Deep refer to multiple layers of neuron used in this network. So unlike traditional, what was the backdrop of what is the disadvantage of traditional machine learning? That it was not deep. It has only few layers, and here in this deep learning model you get deep layers. So unlike traditional shallow machine learning algorithm, deep learning models can have tens, even 100 layers, allow them to learn complex patterns of large data set, and it also produces some representational data based on the input. Now next feature is representation learning. Now what is representation learning? Deep learning models can automatically learn meaningful representations from raw data. This ability to automatically extract features from the data removes the need of manual feature engineering and making deep learning highly versatile and applicable to a wide range of tasks. So this is another feature of deep learning. Another important thing is the end-to-end learning. What is end-to-end learning feature of deep learning? Deep learning models often learn directly from the raw input data to output predictions, making them end-to-end learners. This means that the entire process of feature extraction, representation learning, and decision making is integrated into a single learning framework, and that is an advantage of deep learning. The next point is large data set. That means you can now deal with a large data set. Earlier, when there is a large data set, the traditional machine learning failed because of the complexity of the data. Here in deep learning algorithm thrives when training a large scale data set. The abundance of data help the model generalize better and capture interact pattern in the data. Next, you get so dear friends, we understood the major features of deep learning from these slides. Let's move to our next slide and try to understand a little bit history of deep learning, how it was started, and at the what are the different stages of deep learning. So deep learning is not a very old technology, it is very new. So we can consider there are four different ages of deep learning, and these ages are Bronze Age, Iron Age, Roman time, and Industrial Age. So we can divide the all the advancement before 2012 as Bronze Age. All the advancement between 15 and 16 are Iron Age, and all the advancement during 19 and 2019 and 20 are Roman times, and the all advancement after 2021 is Industrial Age. So here, depending on the major key milestone of this knowledge area, these ages are defined. So if you consider the Bronze Age, then this period show the emerging of early deep learning frameworks like Caffe, Chainar, etc. These frameworks enable the building of complex neural network model and supported multiple GPU training, reducing training time of large models. Then in Iron Age, large tech companies entered into the scene and leading to the development of major deep learning frameworks such as TensorFlow. So you know TensorFlow is a very powerful tool in Python, like PyTorch, then Caffe2, MXNet, etc. So this framework brought improvement in user APIs, multiple GPU support, and distributed training capabilities. Then we see the next stage is Roman times, that is 2019 to 20. The TensorFlow and PyTorch emerges as the dominant deep learning frameworks, and other frameworks like Caffe2 and MXNet are less relevant nowadays. So large model training and usability becomes the key trend during this phase. And if we consider the advancement during 2001 and 2 and now, the success of deep learning in this particular in various fields has changed the world a lot, is giving us more advantages. So the next generation of deep learning frameworks is accepted to focus on the compiler based operation optimization, unified API standard such as NumPy capabilities, and data movement optimization for multi-node and multi-device training are possible in the new industrial stage. Now after that, you can do a lot of research based on those ages. You can study more if you are interested in the technology history. You will find different resources through Google. And let's move to our next slide. What is next? What is the future? What is the future of deep learning? And so the future is bright. It's very simple. The future of deep learning framework is expected to be shaped by advancement in algorithm and high performance computing, hardware accelerators, and distributed systems. So hardwares are now advanced. You can apply deep learning in a distributed system so that it is working in a network of computer. Overall, this particular progress actually is very promising for deep learning based technologies. So now next move to our next slide, the question. Now the question, that you can see the question here: what sparked the excitement in the area of neural network and lead to the rapid development of deep learning frameworks around 2012? So what was the reason why people are interested in this? Very simple, that the excitement in this area of deep learning network was sparked by the proposal of deep learning network architecture known as the AlexNet, and AlexNet achieved the state-of-art accuracy on the ImageNet dataset and outperforming other other relevant models, and these outstanding results showcase the potential of deep neural networks and motivate the development of various deep learning networks. So our next question is, what are some early deep learning frameworks that emerged before 2012 and what were more some of their limitations? So before 2012 there was Chainar, Cafe, etc., Theon. So these frameworks were either not tailored specifically for neural network model development or hard complex user APIs and lack of GPU support. As a result, ML prescriptioners had to do a lot of heavy lifting when using this primitive deep learning model. Okay, now next move to our next slide. What is the question? Question number 3. You can see the question: how did the success of AlexNet and ResNet influence the development of deep learning during the Iron Age? So during the Iron Age, we get different new framework like TensorFlow and PyTorch. So success of AlexNet and ResNet brought a lot of attention to the deep learning and shows deep neural network could achieve state-of-art result in various tasks. With that motivation, tech companies invested in developing deep learning frameworks, and TensorFlow is one of them. And during this period, the frameworks were polished to provide clear defined user APIs and multiple GPU support and distributed training capabilities. Let's move to the next slide, and our next slide is showing another question. The question is, what are the major deep learning frameworks that become dominant in the Roman age, that means during 19 and 20, and what are the contributed to their popularity? So TensorFlow and PyTorch emerged as two dominant deep learning frameworks during this phase, representing over 95% of the use cases in research and production. The popularity of TensorFlow was driven by its association with Google, while PyTorch gained traction due to user-friendly and intuitive imperative programming style. Additionally, frameworks like Chainar and CNTK transactions their development effort to support PyTorch and further boosting its adoption. Let's move to our next slide. Question number 5. What are some technical trends expected to become mainstream in the next generation of deep learning framework in the industrial age, that means after 2021? Some technical trends expected to become mainstream in the next generation of deep learning frameworks include number 1, like compiler based operating optimization. Deep learning compiler like Apache TVM, MLTIR, and Facebook Glow are expected to optimize computations efficiently and any hardware backend. Unified API standards to a move towards adopting NumPy API and the standard of tensor manipulation APIs. New deep learning frameworks to reduce learning curves for using switching between frameworks, then data movement optimization, the treating data communication as a first class citizen in the computational graph, and enhance performance in multiple node or multi-device training scenario. Let's move to our next question. Next question is number 6. Why the development of deep learning framework considered critical for the advancement of API? Deep learning frameworks provide the necessary infrastructure and tools of building, training, and developing deep neural network, which are the backbone of many AI applications. These frameworks enable researchers and practitioners to experiment with new algorithms, work with large-scale dataset, and deploy models in various environments. The development of efficient and user-friendly deep learning frameworks accelerate the progress of AI by making it easier for developers to create sophisticated model and push the boundary of what AI can achieve. Let's move to our next slide, and the question is here: what is a neural network and how does it is related to our human brain? So we have discussed this. You can answer, you can prepare the answer. A neural network is a computational model inspired by the structure and function of the human brain. What is there in human brain? In human brain there are many neurons. So in a neural network there are also some neurons, but these neurons are not like biological neurons. It is a network of interconnected nodes that are known as neuron, arranged in multiple layers, and there is an input layer, there is an output layer. In between that there are many hidden layers. So neuron transmitted information by passing a small amount of electrical charge to each other through connections called weights, and these weights can be strong or weak, representing the strength of the connection between the neurons. And the network learn from input data by adjusting these weights to output to optimize its performance, and much like our human brains learn from experience and mistakes. So let's move to our next question. Our next question is number 8. So what is the question? Describe the functionality of a neural network and its representation in layers. A neural network consists of layers and nodes that we discussed in the previous question. Each node in one layer is connected to every node in the next layer with some weight, and when an input is fed into the first layer, it produces some output, and that output is an input for the next layer. So the value of the nodes is subsequent layers are calculated with matrix multiplications and activation function. The matrix multiplication of weight matrix and input vector followed by addition of the bias vector produces the intermediate node values. An activation function introduces non-linearity in the network, allowing to learn from non-linear relationship in data. The process continues layers by layers until the final output is obtained, which represent the predictions of neural networks for a given output. Okay, now let's move to our next slide. Some answer of the questions will take reference from the previous question, so that is also helpful for learning process. So our next question is, what is the role of a activation function in neural network? So you will frequently use the word activation function. Activation functions are crucial in neural network because they introduce non-linearity to the network, allowing it to learn the model and complex relationship in data. Without activation function, the network would be limited to linear transformation which are not suitable for many real world problems. Activation functions help neuron decide whether to fire or not based on the input they receive, leading to more expressive and powerful representations in the network. Let's move to our next question. Question number, I think question number 9 was, what is the role of activation function in network? And question number 10 is, what is question number 10? Question number 10 is, name two popular activation function and describe their characteristic. So two very popular activation functions are like number 1 ReLU, that is rectified linear unit, and sigmoid. So ReLU activation function become an identity function, that is y is equal to x, when the input is greater than or equal to 0, and it becomes 0 when the input is negative. It is widely used due to the simplicity and ability to introduce nonlinearity effectively. Another is sigmoid function. The sigmoid function squashes input values between 0 and 1. It is bounded and used in scenario where binary outputs are required, such as binary classification problems. What is the next question? Question number 11. Why nonlinearity essential in neural networks? Nonlinearity is crucial in neural networks because real-world data often exhibit nonlinearity relationship between input and output variables. Without nonlinearity activation function, the network would be limited to modeling linear relationship, which can lead to poor performance in complex tasks. By introducing nonlinearity through activation function, neural networks can better approximate and learn from data with interact patterns and dependencies, improving their ability to solve challenging problem effectively. What is our next question? Our next question is, what is the purpose of the hidden layers in a neural network? So hidden layers plays a very significant role in a neural network, and in learning complex representations and features from the input data, it is very helpful. These layers are responsible for transferring the input data through a series of nonlinear transformation, allowing the network to capture the patterns and relationship between the data. The hidden layers enables the network to learn hierarchical representations and make it capable for solving more sophisticated and challenging tasks. What is our next question? Our next question is, explain the process of training a neural network. So how to train a neural network? Training a neural network involves presenting the network with input data or training sample data and adjust the weight and bias iteratively to minimize the difference between the predictive outputs and the actual targets. This is achieved through an optimization process called backpropagations. During backpropagations, the network calculates the gradients of loss function with respect to the network parameters and update the weight and bias using gradient descent or its variants. The process continues for multiple epochs until the network converges to a state where the loss is minimized, and it can make accurate prediction on new unseen data. Let's move to our next question. Our next question is, what are the challenges of training deep neural network? Training deep neural networks can be challenging due to several reasons. Reason number 1, vanishing gradients. So what is vanishing gradient? In very deep network, gradients can become extremely small during back propagation, leading to a slow convergence or no learning at all. Number two, the reason is exploding gradient. Conversely, gradient can become large, causing uh, numerical instability and difficulties in optimization. Another reason is overfitting. What is overfitting? Deep networks with a large number of parameters are prone to overfitting, where the model perform well on the training data but poorly perform in case of new data. And another reason is computational complexity. As the number of layers and neuron increases, the computational resources required for training also increases significantly. What is our next question? Our next question is, how can you address the issue of overfitting in a neural network? So there are several techniques that you can apply for addressing the issue of overfitting in a neural network. Number one is regularization. What is regularization? Adding regularization terms to the loss of functions such as L1, L2 regularization, then penalizing large weightage and encouraging the network to use simpler models. Then dropout randomly deactivates some neurons during the training and preventing the network from relying too heavily on specific neurons and promoting better generalization. Data augmentations, generating additional training data by applying random transformation to the existing data help increases the diversity of the training set, reducing the risks of overfitting. Early stopping, monitoring the validation performance during training and stop when it started to degrade can prevent the network from overfitting the training data. Now let's move to our next question number 16. What is, how does transfer learning benefits the training of deep neural networks? So what is transfer learning? Transfer learning is a technique that leverages knowledge from pre-training model on one task and applies it to a different but related task. It benefits the training of deep neural networks by reducing training time. Transfer training allows you to start from the model with already trained representation, reduce the number of epochs needs for convergence, improving performance. Pre-trained model have already learned useful features from vast amount of data, leading to better generalization and performance on the target tasks with limited data. And handling data scarcity, transfer training enable the use of pre-trained model when the target task has limited label data, effectively address the issue of overfitting in such scenario. So these are some process how you are transferring the learning benefit in training a deep neural network. Let's check our next question. Our next question number 17. What is the main objective of machine learning? The main objective of machine learning to enable computer or machine to learn from data experience and use the knowledge of making predictions and or decision without being explicitly programmed for specific tasks. What is our next question? Question number 19. Name and briefly explain the three main types of machine learning. So you already know what are three major types of machine learning are: supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? In supervised learning, the algorithm is trained with a labeled data set containing some input and output pairs, and the goal is to learn the mapping between the input variables and the output variables. So here input variables are independent variables and the output variables are dependent variables. In it can be further categorized into regression and classification. Regressions mean continuous output, and classification is relevant to categorical output. So there are basically two types of tasks: regression and classification tasks. Unsupervised learning is the algorithm that is trained by unlabeled data set containing only input data. The objective is to find the patterns and structure in the data without any specific output variable, and that include clustering and association are common tasks in unsupervised learning. Reinforcement learning involves an agent and learns from interacting with an environment and receiving rewards or penalties based on the action. The agent's object is to minimize the reward, and it learns from all those rewards. So it is kind of trial and error kind of things during learning. So we understand different types of machine learning. Let's move to our next slide, question number 20, and the question is, what distinguishes deep learning from traditional machine learning algorithm? This is a very interesting question. Why you need machine learning, and why machine learning was defeated by deep learning. So deep learning is a subfield of machine learning, and it is specially focused on artificial neural network. So while traditional machine learning algorithms are effective for various tasks, deep learning algorithms have the ability to automatically learn hierarchical representation from the data. Deep learning algorithm can handle large-scale complex data set and can discover patterns and relationship that can be apparent from can be apparently using the traditional model. It was difficult. So deep neural networks are capable of handling feature engineering and reducing the need of manual intervention for feature extraction, and it is applicable for large amount of data set as well. Let's move to our next question. I think I answered why deep learning was required. And next question is, what was the key factor that contributes the rise of deep learning in recent years? The rise of deep learning in recent years can be attributed by two factors. Number one is the availability of computational power, because we have more powerful hardwares available now that has high powerful GPUs, that is graphics processing unit. The advancement of this hardware like high powerful GPUs provide the necessary computational power to train deep neural network efficiently, and it makes large scale deep learning possible nowadays. So it is feasible, technologically feasible, not feasible in the previous hardwares, previous version of hardwares. So another is abundance of data. We are producing tons of data every day, and due to that availability of large amount of data set, deep learning models are capable to learn from vast amount of data and information, and that result the improvement in this area. Now let's move to our next slide. Our next question is, mention some application of deep learning. So deep learning is widely utilized in all AI driven systems. Deep learning are found in various fields. Some examples are self-driven car. So deep learning algorithms are used in enabling the automobiles vehicle to perceive the navigation in any environment. Then voice search or voice virtual assistants, you can speak with computer. So speak recognition and natural language processing techniques based on deep learning are employed in the voice based application. Machine translation, like deep learning models are utilized for improving the accuracy in the machine translation system. Then image capturing, deep learning techniques are used to generate descriptive captions of image. Then game playing AI, deep learning models are demonstrated in different type of games, and these are you can play with computer just like human competitor. And real object recognition, now computer can recognize object, like you can see the use of uh, object recognition in the tools like Google Lens, like take a picture and you can search that object in Google. That is possible using deep learning. There are many other uses in deep learning is possible. Let's move to our next slide. Next question: what are the advantage of using deep learning over traditional machine learning algorithm? So we have already discussed the difference between the machine learning, advanced machine learning, and deep learning. So deep learning offers several advantages compared to traditional machine learning algorithm. Number one is it is automatically feature learning tools. So your model is capable to capture feature from large amount of data. So deep learning algorithm can automatically learn hierarchical feature from raw data, reducing the needs of manual feature engineering, which is common in the traditional machine learning. Then handling large data set, deep learning is capable to handle large amount of data set, and traditional machine learning is not capable to handle large amount of data set. And you can also see better performances in case of deep learning. Deep learning models are efficient, and deep learning excels the solving some challenging problems such as image and speech recognition, natural language understanding, playing strategic games like a competitor with human. And traditional machine learning were not capable to do this. And the scalability, deep learning model can be largely scaled to more extensive architecture and allowing more parameters and layers, and traditional machine learning is not capable to do this. Let's move to our next slide. What are some key components of deep learning architecture? So there are few key components in any deep learning model. Number one is input layer. The first layer that in a neural network that receive the input is called the input layer. Then hidden layers. Hidden layers are the intermediate layers between the input layers and output layer, responsible for learning and extracting representations from the data. And output layers, the final layers that produce the predictions or output based on the learned representation. And then another is weights and bias. Weights and bias, the learnable parameters of the networks that are adjusted during the training process to minimize the loss and improvement predictions. And then activation function. Activation function, non-linear functions applied to the intermediate nodes values in the hidden layers, introducing non-linearity and enables the networks to model complex relationship in data. So there are major components are input layer, hidden layer, output layers, weights and bias, then active function. So active function is non-linear function applies to the intermediate node values in the hidden layers, introducing non-linearity and enabling the network to model complex relationship in the data. I think you can remember this point for answering this question. Let's move to our next question, question number 25. How does reinforcement learning differ from supervised and unsupervised learning? So it is not related to deep learning. It is a question relevant to machine learning. But you can expect this kind of question during an interview because the employer also want to know your understanding about machine learning, because machine learning is the largest set that contain deep learning. Reinforcement learning differ from supervised and unsupervised learning in following way. In supervised learning, the algorithm learns from label input output pairs to make prediction or classification. The algorithm aims to minimize the prediction error during training. Unsupervised learning, the algorithm learned from unlabeled data and aims to discover the pattern and or structure within the data, such as the clustering and similar data points, and actually they keep together all the similar data points. So in reinforcement learning, you are giving some award or reward to or penalizing the model based on the output or prediction. So this algorithm learns by interacting with an environment and receive feedback from it as a reward and penalty based on its action. The agent goal is to learn the optimal policy to maximize a cumulative reward over time through trial and error. And reinforcement learning is more common in sequential decision making tasks such as game playing or robots, action of robots, and these questions and answer played additional insight into the benefit of deep learning, this key component of deep learning architecture, because if you don't understand what is supervised and unsupervised learning, then it is difficult to understand what is deep learning. Let's move to our next slide. Our next question: what are the main differences between deep learning and traditional machine learning? So it is a repeated question where I think we already answered this. You can check out in the previous. The next question is: how does deep learning makes use of unstructured data? That is a good question. So deep learning is particularly effective in utilizing unstructured data, which comprise various type of format like image, text, and more. Unlike many machine learning algorithms are struggle in analyzing unstructured data like text and image, so deep learning algorithm can process different data format and train from that. So for example, deep learning algorithm can analyze industry like it can analyze social media comments and news feeds and etc. Now let's move to our next question number 28. What are the advantages of using deep learning over machine learning? Again, it's a repetitive question, but I think we already discussed this point. Major point are maximizing the utilization of unstructured data. Traditional machine learning is failed during the processing of unstructured data like text and images. It eliminates the needs of feature engineering. In traditional machine learning, you need to do something as feature in engineering as a manual task, but here deep learning you don't need this manual work. And ability to deliver high quality result, because machine learning is deep learning is more accurate. It is eliminating the unnecessary cost. It is eliminating the need of data labeling. So these are the major advantages in deep learning. Let's move to our next question. What is our next question number 9? How does deep learning handle feature extraction without explicit guidance? So in deep learning, feature extraction is handled through hierarchical learning process. The neural networks architecture consists of multiple layers, and these layers learn to detect specific patterns and features from the data. In the initial layers, the network learned low level features like edges and gradients, while in deeper layer it learned some complex and abstract features. Through multiple layers of learning, the model automatically identify relevant features that correlate and combine them to perform tasks effectively. These ability to automatically learn features without explicit guidance is one of the key strengths of deep learning. Let's move to our next question. What is our next question? Question number 30. What are the major phases in deep learning process? So the major phases are training phase first. In training phase, a deep learning model is exposed to a large amount of labeled data, and it identifies the patterns and features from this data, and the system compares the characteristics and memorize them to make correct conclusion when encounters the similar data in future. The training phase involves adjusting the weight and bias of the neural network and minimize the error and improve the performance. And then the next phase is inferring phase. So during this inferring phase, the training model makes a conclusion and label new unseen data based on the knowledge it gained from during the training phase, and the model uses the learned features and the patterns to make prediction or perform tasks on new data. Let's move to our next question. Our next question is, what are the three popular approaches uses to perform object classification in deep learning? So what is object classification in deep learning? There are three popular approaches used in object classification in deep learning. One is transfer learning. The approach involves fine-tuning a pre-trained model of a new task by modifying the pre-trained network and providing fresh data with previously unknown classes. The model can perform a new task such as recognizing specific object without need of an extensive training data. Training from scratch. In this approach, a deep learning network is trained from scratch during a large label dataset. It requires a large label dataset and designing a network architecture that learns feature and mimic the problem of the domain. And the approach is effective for new application or tasks with a large number of output categories. Feature extraction. This specialized approach involves using pre-trained network and as a feature extraction. Each layer of the network learns specific features from the input data, can then use input to traditional machine learning model. What is our next question, dear friends? Our next question number 32. How does deep learning contribute to various industries? Okay, now you can guess this. I don't need to answer because we have already discussed. If you have watched this video from first to the now, you can answer this. Number one, you can see the use of deep learning in automatically driven cars. So deep learning helps in detecting objects like traffic lights, signals, then pedestrians, and improve the safety and reduce the accidents in autonomous vehicles. Then you can see the use in medical research. Deep learning is applied in cancer research, like automatically detecting the cancer cells and assisting in early diagnostic and the treatment. Then electronics. Deep learning is used in automated speech translation of home assistance device that responds to voice command and understand user preferences. Then this example highlights the range of application where deep learning enhance the performance and automation process and bring value in the industry across different domains. Okay, let's move to our next question. What are the significance of deep learning in eliminating unnecessary cost and defects? Deep learning plays a crucial role in eliminating unnecessary cost and defect in various industries. Like deep learning models can identify defects of products such as minor labeling errors and hard to train using traditional method. So it helps in maintaining product quality and reduce the need of expensive recalls. And robust inspection. Deep learning can account the variation or in image and learn valuable features, making inspection more robust in the challenging condition. By coefficiently identify the defects and the error, deep learning reduce cost associated with the product recalls and enhance overall quality and control process. Let's move to our next question. What is our next question? Question number 34 or 33. Okay, what are the significance of deep learning in eliminating the cost and defects we have already discussed. What is our next question? How does deep learning differ from traditional machine learning algorithm in terms of learning high level features? So it is a very simple answer. Deep learning algorithm differs from traditional machine learning algorithm in terms of learning high level features. The traditional machine learning domain expert needs to identify and extract relevant feature from the data manually to make the patterns more visible to the learning algorithm. On the other hand, deep learning algorithm try to learn high level features directly from the data in a incremental manner, and this eliminates the need of domain experts and allows the model to automatically discover complex and abstract representations from the raw data, and making it more flexible and capable of handling a wide range of tasks. Let's move to our next question, question number 35. How does deep learning achieve its power and flexibility compared to traditional machine learning? So we have several times discussed this point. Just in simple word, like deep learning technique learn categories incrementally through the hidden layer architecture. It starts by defining the low level categories first, such as the letter in case of language processing, and then move to the more abstract representation like word. Then each neuron or nodes in the network represented one aspect of the whole, and together they provide a comprehensive representation of the output data. These hierarchy learning process allow deep learning models to capture complex patterns and relationship, lead to supervised accuracy performance when training a massive amount of data. Let's move to our next question. Our next question is, what are the distinctive features of deep learning that makes it popular? So we already discussed this. The major points are the data driven powers. So you can deal with big data. Feature extraction, you can see deep learning can do feature extraction. You don't need domain expert for that. End-to-end problem solving, and it is providing you an end-to-end problem solving because of its efficiency compared to the traditional machine learning. And faster testing process, you can deal with a large amount of data set. One limitation of deep learning is lack of interpretability. It may achieve excellent performance but often fail to explain the reasons behind the decisions. That is one limitation of deep learning. It is which is a critical aspect in certain sector. It can tell you the output, but how that output is achieved, this is not clear from deep learning. Dear friend, now it is time to summarize what we have learned from this particular class. It is a very short introductory class for people who wants to understand what is deep learning from beginner level. So deep learning has undoubtedly become a game changer in the field of artificial intelligence. If you want to learn artificial intelligence, then this is the first step. After getting some idea of what is machine learning, what is business analysis, then you can start learning what is deep learning. Okay, so deep learning, what are the features you are getting in deep learning? It has revolutionized the AI. Deep learning has revolutionized the field of AI by enabling machine learning to learn from data and perform complex tasks such as image recognition, speech recognition, natural language processing, and more. And it is improving its accuracy day by day. So you can deal with large amount of data, so big data, and whatever the scale, it doesn't matter. Deep learning can deal with a big amount of data, and it offers the opportunity to get solution from a range of applications, and it has automated various processes that is saving times. So once you train a model, it can save a lot of time. It is definitely improving the productivity of the industry. It is very versatile. There is a broad spectrum of industries like healthcare, finance, manufacturing, entertainment, making getting some use of deep learning, and they are improving their performance, improving their activities. We get competitive advantage with the help of machine learning, with the help of deep learning. uh, Businesses and organization leverage their activities with the help of deep learning because they are gaining more information from the data, and it is helping them in better prediction, optimizing the process, and enhancing the customer experience. So it is a very state of art results. Like deep learning has consistently outperforming the traditional machine learning techniques and setting the new benchmark, and the progress is going. If you learn this, you will be up to date with the new advancement. You also get some other benefit, like transferring the learning to pre-learning models. Like deep learning allows transfer learning to uh, for the next iteration, or the for the next stage. Then interdisciplinary impact, like deep learning impact extending beyond computer science. It is influencing other fields like healthcare, innovating new drugs, and solving various type of healthcare issues. You can see its implementation in robotics, and one more thing is you are getting various type of open source tools like TensorFlow, PyCharm, Keras, etc. So these are giving you facility to use those technology as a programmer, as a developer, as a technology expert. And the generative deep architectures, like these architectures are designed to generate new data samples that resemble the training data set. So when you are driving a car, it is taking a picture of the surroundings, and it can generate a new environment when it is progressing to a new road, unknown road. So dear friend, we can use hybrid deep architectures. Hybrid deep architecture combines the features of both generative and discriminative architectures. They primarily aim for adding some improvement in optimization, regularization, and combining of generative and discriminative aspect often lead better performance in the challenging tasks. Feed forwarding networks, you are getting by feed forwarding network, we are getting a network which is actually learning from the previous tasks and using that knowledge as an experience for solving new tasks, just like human brain. And of course the use of convolutional neural network like CNN are well suited for image and video related tasks. They can use convolutional layers to automatically detect hierarchical pattern and features in the data. The CNN are particularly effective in image recognition tasks and achieving state-of-art performance in detecting the objects. And there are recurrent neural network, or RNN, that is designed in the process of sequential data processing, sequential data. And these are helpful in language modeling, machine translation, and speech recognition. So there are many uses of deep learning. In a future video, we'll do a real project on deep learning, and we'll do some coding using TensorFlow for understanding deep learning in a better way. So stay tuned and subscribe this channel for more updates like this. I hope this conversation is helpful for you. Some parts are a little bit full of various technical words. I totally understand this. So if you study them, you can do research on those unknown phrases and unknown terminologies, and you can gain better understanding. So my suggestion would be keep learning, and one day you will get more confidence on this. And I'm still learning. If there is any error, then mention this in the comment, then I will try to improve in the next next session of deep learning. See you guys in the next episode. Please subscribe this channel for more updates like this. See you in the next episode.